I need I'm in a meeting. I'm in a meeting.
Oh, evening is a boys. That's video.
Right, good afternoon, everyone. I hope that I'm audible on the other side. And if I can just ask if all of our mics can just be switched off and also the cameras.
So what happened? Like he was
And then just to remind everyone also that this session is being recorded.
but it's not the first time I have seen you outside many times. I just want the principal to do it.
Okay, there's still some of the mics that are not switched.
Because you said at the end of the game, ma'am has to account.
Everyone to pick up the mic and then
And
just
you will promise and you will sign. You will write in the logbook and
otherwise I will
sign.
have to mute everyone. Okay, I've muted everyone. So, ladies and gentlemen, welcome to this presentation or to this marking guideline discussion. As I can already see in some of the classes, there are more than one educator. So, I just make sure that we have just admitted everyone. We are still just admitting quite a few, and then we can just get started over here. I'm just still admitting a few of our members. So next to me here, I've got our internal moderator for the past 11, 12 years, Mam Stefani now. So she's also participating today in this marking guideline discussion. And she will also keep an eye on the computer if there's still people that we need to get admitted to our sessions. But ladies and gentlemen, I'm about to start over here because the first part of our presentation is mainly about looking at those general aspects that we actually want to deal with. So I just want to move this over here. Here with my slideshow. I hope it's visible on the other side. And that you were able to see it. Right, so ladies and gentlemen, please just make, at any time, if there's something that if I cannot see your comment or anything, you're more than welcome, just unmute yourself and then just quickly pop in here with a comment or two, because I won't be able to always keep my eye there on the computer. But ladies and gentlemen, what I want to get started about is the following, and I hope that I'm audible on the other side. So, welcome to our marking guideline discussion for mathematics paper 2 in the Northwest Province. Now, I'm starting over here by saying, if we look at, some people want to be admitted, I'm just quickly admitting them. So if we look over there, our exams are benchmarked against other countries. So our curricula cover higher order thinking skills. So this is something that we also need to remember. Because the reason why I'm saying this, we are not here to contest our question paper. The paper was already written. We are here to look at our marking guideline discussion. Let me just see if I can just get the next point here. Sorry, something's just happening on this side over here. Ah, there it is. Now also, marking is not the same as teaching. So we need to understand that. So teaching is about getting learners from one point to another point and making sure that they understand everything. Marking is about a judgment, and I put it in inverted commas because sometimes it can sound harsh, but it's really about a judgment, and we can only judge what we see. So what is very important here is when we do marking, when we are doing assessment, the learners are telling us, listen, this is our response, this is our solution. We want you to assess us on this. So we are not supposed to think for the learners. So therefore, when you mark, you can only allocate marks for that you are actually seeing. That's actually happening over there. Now, if I go to the next slide over here, there are quite a few points I would like you to consider. Now, the first point I would like you to look at is the marking guideline versus memo. Now, some of you are still making use of the terminology memo. So memo is I'll explain to you why. So rather, we would be looking at marking guidelines. That is the terminology. The next one over there is we are going to look at error versus mistake. So you might think it's the same. It's not exactly the same. So it's error versus mistake. There's a fundamental difference. And it's because of that fundamental difference that we can look differently in terms of the way we are marking our question papers. Now, I would also like to talk to you about solving or showing versus verification. What is the difference over there?
Right?
Also,
We have a memo
about
discussion.
the cognitive level of the question. And then also a very important aspect, I would like to talk to you about the history of the answer script. Okay, so those are the things that I will be actually looking in the first part of our marking guideline discussion. Now, as I mentioned, we no longer talk about memos. We only talk about marking guidelines. And the reason why we call it a marking guideline is because a memo is what is actually cast in stone. You cannot change it. So you cannot deviate from it. That's the only thing that we can actually allow to award marks. Marking guidelines, the word itself telling you, but listen, it's a guideline. It's only guiding us. So it means it keeps the door open. It keeps the door open for something else. Now, if we bear in mind that we've got at this specific case over here, we all know what this is. This is CAPS, okay? So you know the CAPS, you know the curriculum assessment policy statement. CAPS is telling us what we are supposed to teach, up to which level we are supposed to teach it. So that's all coming from CAPS. Now, we also got this little book over here that's called our exam guidelines. But now, if we only focus on CAPS and we only focus on exam guidelines, and we want to cast that in stone, then along the way, we are going to disadvantage learners because sometimes learners may use methods that are not actually covered in CAPS. They are not actually covered in the exam guidelines. Those markers that have been marking Maths Paper 2 for quite a few years now will tell you. But sometimes when learners have to find the area of a triangle, they can make use of the shoelace methods, which actually just something back to matrices and everything. Or if we've got the sides of a triangle, we can make use of Heron's rule, you know, whatever the case might be. But that's why we call it a marking guideline, to say we need to keep the door open for alternatives. That's very important. So on your marking guidelines, sometimes you will see, but the response of a learner looks something completely different. And then that means that if the answer is correct and the method is correct, then that should become an alternative. Now, ladies and gentlemen, those of you who don't know me, I'm Mornay Smit. I was the chief marker for the past 8-9 years in mathematics for paper 2. But now I'm giving the baton to someone else because I got promoted in the meanwhile. So, but for this, if you doubt about an alternative, the majority of you've got my phone number. You can send it to me. I will look at it, and then I will even consult with the current IM to see how we can award marks to also make it a little bit easier for all of you. So you're more than welcome. Now, if I have to move on to the next slide. So therefore, the need for variety. So this is just something that you can have a look at. That's something just to think about. We must be open for variety of responses. I know maybe you taught it in a specific manner, but remember, some of your learners may have gone to the winter camps. They may have looked at some YouTube tutorials. So sometimes they see people doing it in another way that's sometimes more easier for them. And so don't let us disadvantage them. So let us be open also to varieties. Therefore, it's only a guideline and not a memo. Now, errors versus mistakes. Okay, so if we look at the word errors versus mistakes, some of you can say, listen, those two words, they mean exactly the same thing. There's actually a fundamental difference between error and mistakes. Now, let me just explain it in this manner to you. Errors can be caused by calculators. So errors in mathematics, when we talk about an error, we talk about a calculation.
Is it possible or I increase the number of
Alex, can I just
participants?
ask to mute yourself, please?
Maximum.
Thank you.
Gosh, I'm not.
Okay, I've muted the member. Now, also, so errors can be caused by calculators. So sometimes learners can punch things into the calculator and then they get a wrong answer from the calculator. And that is what we call, that's what we call an error. Now, a mistake is what's mainly caused by the ways of thinking. So mistakes, we link it with the brain, and errors, we link it with the calculator. Now, why am I mentioning this? Because if you look at the marking guidelines, we would tell you stop marking after the second error or stop marking at the second error. So that means that a learner makes a calculation mistake and they make another one, then we stop marking. But when it comes to a mistake, you're not supposed to even mark after the first mistake. You're not even supposed to mark with the mistake, okay? So when it comes to mistake, that is what we call the thinking error. And that is what we don't want to see in mathematics. So therefore, under marking guidelines, we would say stop marking at the second error. So it means one calculation error is allowed, but if they make another calculation error, then it means that we are not going to follow up on that. But when it comes to a mistake, the way that they are thinking, then it means that if there's a fundamental mistake in the way they are thinking about a specific problem, then it means that we're not even going to mark that. We're not going to look at that because already the learner is telling us that they don't know how to attempt to do the problem. Now, also the thing about understanding. We've all heard about the great Einstein that always said, if you can't explain it simply, you don't understand it well enough. Ladies and gentlemen, don't let us be too judgmental when we mark our learners' answers. We have to look at their response and the way they want to present the response. So we can't just go, listen, you don't know nothing, so therefore we're going to leave it. I must tell you, I've been completely privileged. One of my DCMs for many years, one of my deputy chief markers from the Maribeng area, she would always, when it looks like there's a lot of nonsense being written in a grade 12 answer script, she always manage to find marks from that, because within that response, the learner is actually presenting a part of the solution. So that is going to say, but it's not explained simply enough. We have to look at the whole response of the learner. Then also, if I can move on over here to the next one, I'm seeing some of the comments over here. Yes, that would be nice if everyone can mute their mics. Now, solving or showing versus verification. Now, because the majority of you are experienced mathematics educators, we've all seen this sort of questions where they would ask you in the question paper, show that. In Afrikaans toon aan, or solving. Now, what is solving or showing versus verification? Because there's also a difference between those two concepts. Now, let me explain to you what the difference will be. If I give you this equation, so let's say this equation is given 2x minus 8 equals 0. And the question is that you need to prove, or you need to show, you need to prove that x equals 4. Now, let's look at some of the ways the learners may actually want to do this problem. Now, some of them would immediately substitute 4, and they would say, but 2 times 4 is 8, and 8 minus 8 equals 0, so therefore x equals 4. Ladies and gentlemen, this is what we call verification. So they are only verifying if 4 is part of that solution. But in mathematics, we are not interested in verification. We are interested in the problem solving of that equation, the solving of that equation. So therefore, we would rather be looking at something like this. Now, I've made use of something very easy. So we would try to see how they transpose the 8 to x equals 8, how they divide by 2 on both sides, and how they get x to be 4. So the second part, that is where the equation was solved. The first part is only where they verified it. So we need to understand something. If we tell the learners to show something, it means they must show us where that 4 came from. They are not allowed to use the 4. So sometimes when you do marking, you will get learners that would do this, and then sometimes it would baffle you a little bit and you won't know what to do with it. Always ask yourself, is this learner verifying it, or is this learner actually solving or showing it? Now, I know where the point of confusion can come in, because within functions, they can ask us to show that this coordinate lies on this specific line. And then the learners will substitute it in and they will get another value, and that's how they would actually go about it. But remember, that's with functions. On a specific lines, there are millions of coordinates points. So therefore, they have no other choice but to use whatever we gave them at a specific case over there. But always look at verification versus solving the equation. Colleagues, let us just please remember to mute as well. Now, the second part over here, or the next part, is about the cognitive levels of the question. Now, remember, ladies and gentlemen, if we can go back to the first opening statement where we said that our exam needs to be benchmarked against many other countries across the world. So therefore, within our question paper, we are allowed to differentiate between the different cognitive levels. So if you look over there, knowledge is 20%, routine procedures 35%, complex procedures 30%, and problem solving about 15%. Now, I want to tell you beforehand that it doesn't, whether you look at the provincial paper or the national paper, when we look at the grid analysis, where we actually tell you what type of level a specific question is, remember, that can be very subjective. I would say, except with your routine procedures and your knowledge. So when it comes to problem solving and complex, sometimes that there's a little bit of subjectivity that's actually that we can get over there. So therefore, we may differ at times, but that is why the paper can be differentiated amongst those different levels over there, because we really want to make sure that we've got still good quality papers. But as I say, we're not here to contest the question paper because the paper is on standard. However, I can understand it will be a question here or there, but now we're only here to do with the marking guideline. Now, the next slide over here. So as we already said, if we differentiate our questions in the question paper, there will be some easy question there will be some medium questions, and there are some difficult questions that we have to look in. Now, the reason why I'm showing this to you, because this also influences our marking. This also influenced the way the marking guideline was set up. Because if it's an easy question, we would really like our learners to get their marks. We would really like them to have access to those marks. Even the same with the medium questions. But when it comes to those higher order thinking questions, there we are going to be very stingy with our marks. There we are looking at accuracy, and we want to really know that the learners are understanding what they are doing over there. Because we need to understand the future engineers of this country, the future medical doctors of our countries, they are the candidates that are actually competing for those scores up there within the difficult questions. And we really want to make sure that if a learner gets marks for difficult question, they should deserve it. They should actually know what they are doing. But for easy questions, if you look at the marking guidelines, at certain stages, we will ignore certain things and would say, but we can allow you to get the marks over there. But that's the reason why. So I don't want you to say, but listen, sometimes we are being inconsistent because now you give it here, don't give it there. Look at the grading of the question. If it's a lower order question, we really want the learners to get those marks. If it's a higher order question, it's very important that learners should be mathematically 100% correct in what they are doing. Now, if we look also there, if you can ask, but why do we have some difficult questions in our question papers? And also, sometimes the response a learner can give to you may be on such a level that you will have to read through it 2 or 3 or 4 times, okay? But we need to understand that we really get some learners that are very clever. So once they make use of other methods, please don't let us just think it's wrong. Let us consult each other. You know your subject specialist. You know people that's been involved with the marking processes for so many years. And as I already say, you can, if you put it on the group, we will look at the alternatives and we will see how we can also assist, because this is our marking guidelines. Now, also over here, I always ask myself, when I mark a question, what was the aim of the question? So you will constantly go, what was the aim? What was the aim? What was the aim? That is what we will always ask ourselves. Because if we know what the aim of the question was, it's a lot easier to actually mark that specific question. So let me give you an example. If we ask the equation of a perpendicular line, then sometimes you will get learners, they will work with the coordinates and they will get a gradient, and then they will change the sign, but they will not change the value. And then for us, that is wrong, okay, because there's a little bit of a mistake in the way they think about that. But if they make, the second part is to find the equation, it means that they still have to substitute it. And they still have to arrive at the specific equation. So we have to ask ourselves, what was the aim of the question? The aim of the question was to get the equation. But to get to the equation, there are so many things that the learner had to think about. And that's why we don't really just want to give a 0 when they made a little bit of a slight mistake over there. We really want to make sure that we actually think it through very nicely. Now, ladies and gentlemen, this was I'm going to stop my PowerPoint here because I want to get into our marking guideline. I'm still admitting a few of our colleagues over here. I just want to get out of the PowerPoint over here. Okay, now I can share the marking guideline with you. And I believe that all of you already have your marking guidelines, so that will not be a problem. And I just want to take us up over there. Okay. So there's our marking guideline. Now, ladies and gentlemen, as I say, because we've got only limited time to actually work through it, but we really want to make sure that from this session that you can say, but listen, I'm more equipped and I'm more, how can I put it, in a position that I know what to do and how to do with this. So therefore, that is why we are doing this. So whenever there's a question, just put it in the chat box. We will see where we can assist and how we can help. I just say, okay, they're saying we've reached our capacity. I don't know. Let me just check over here. All right. But in the meanwhile, I think we're just going to carry on here. Okay. So I hope, and I think that you will be able to hear me more audible now. Let me just quickly hear what Mr. Mukuma is saying on this side. Sorry, colleagues. Then I will be able to just. Oh, sorry, colleagues. We're just trying to solve that. It looks like we've got more educators who would like to join in, but we've already reached our capacity over here. I will share also the recording that I will do. But I think in the meanwhile, let us just carry on over here and let me just share our walking guideline with you again. It's been shared. Yes. If you can just check someone's mic, that all our mics are on mute, please. Now, if we go through this over here, if a candidate answers a question twice, only mark the first attempt. So this is not something new. The reason why we do this because the candidate should not force us to think for the candidate. This is the very important thing. Okay. So we are not allowed to, the candidate cannot force us to think for him. So therefore we mark the first attempt. This is what we can do. Now, if a candidate has crossed out an attempt of question and has not redone the question, mark the crossed out version. So this is not something that is totally new. This is something that's been happening for many years at national level. So if they crossed it out, they don't redo it, we can say, but let us look at that specific question. Now, how do we know the question was not reattempted? If the learner decides to cancel out 6.2, and in the additional space they started by writing 6.2, that is enough evidence that they wanted to reattempt it. So therefore, we're not going to mark the crossed out version because the marker already put down 6.2. Now, consistent accuracy applies in all aspects of the marking guidelines. So stop marking at a second calculation error. So what do we mean about consistent accuracy? Remember, I already said that a learner can make a mistake with the calculator, but the moment the mistake is caused by the way we are thinking, then that means we are not going to award any marks for that over there. So please, so let us make sure if it's a calculation error, it means that we can still carry on, okay? But in that specific place where we know the mistake, over here, someone's just, I just want to try to mute this person that is making this noise, but I can't find the person. Okay, so let us go on. But also, assuming answer values in order to solve a problem is not acceptable. We're not allowed to do that. So please make sure that you cannot assume anything for that reason. in geometry, we can assume the angle to be a variable, but we can't assume it to be a specific so we have to make sure that don't assume any values over there. Okay. Now, ladies and gentlemen, let us look at question 1. And I believe that you all can see my screen over there, so that will not be a problem over here. Now, if we have to look at question 1, I just want to get my documentation also over here. If we look at question 1, so question 1, we asked the histogram over there. So the first one, how many players were in this rugby squad? Okay, and the answer is 33. There cannot be any answer than 33, so that's accuracy. So we have to work with accuracy over there. Now, in 1.2, now I'm going to tell you 1.2 is going to be a CA mark. And let me explain to you why 1.2 will be a CA mark. Because in 1.2, they ask us to give the estimated mean age of these rugby players. Remember with stats, everything is estimated. So what is going to happen is we are going to look at our first value. They're going to use the frequency multiply by the mid interval between 20 and 24. So that has to be 22. The next one, we look at the frequency. It's 8 times the mid value in that interval is 26. Plus, the next one, the frequency is 15, multiply the mid value is 30, and so they carry on. But now, where does the consistent accuracy come in over here? Now, what is not negotiable is that this we want to see that the denominator in that specific case and the numerator, if you look at our numerator over there, we want to make sure that we see that 2 times 22, 8 times 26, 15 times 30, 6 times 34, 2 times 38, and that has to add up to 982. So that's what we want to see. We either want to see the method or we want to see the 982. Now, we can see over here if it's divided by 33. But now remember something. If they write in 1.1 that there are 30 players, then obviously they can divide with 30 in 1.2. That would be a consistent accuracy. But they can also divide by 33. So don't go to say, but now in 1.1 they say 13, 1.2 they say 33. So this kid doesn't know what they're doing. Remember, for 1.2 they can actually look on the histogram again. And then they start adding up and they see 33. But it's very important in this specific case that it's for 982 and it's for the final answer of 29.76. The learner can also make use of the calculator if they put on a frequency column graph over there, or the column, the table method, and then they will get a 29.76. That is what they will get over there. Now, at 1.3.1, over there, they have to use the histogram to complete the cumulative frequency column in the answer book. Now, if you go to the answer book, obviously they've got the frequencies that they will have over there, and they have to complete the cumulative frequency column. Now, in that column, there's 2, 10, 25, 31, and 33. Now, how are we going to give marks over here? So, ladies and gentlemen, the best way to mark this one over here is when we look at the 2 and the 10. Those two we want to see for 1 mark. So you look, if the 2 is there, the 10 is there, you give 1 mark. And then the last mark over there goes for the 33. So if the learner has something wrong over there, in this case, in terms of the marking guideline, that learner will still be then protected, because we assume that if the learner made mistakes over there, they will not be able to end at 33. So the first mark is for the 2 and the 10, and the last one we want to see if the 33 is over there. So that would be our 2 marks. And if you can look at it in this way, we are really trying to make sure that the learners actually get marks at this stage. 1.3.2. If we look at 1.3.2, draw an ogive. So if we look, there's our ogive. They had to make use of the ogive in the answer book. And now, how are we going to give our marks over here? So the first mark goes for the grounding. So the grounding, it's over here at 20, 0.0. There it's over there. That's where we want to see our grounded. So that would be our first mark that we want to give over there. Now, the second mark, you're looking at the plots. Now the learner is plotting the ogive at the upper limits correctly. So therefore, the learner is making use of the upper limits of the 24,2, the 28, whatever they go up to. We have to look at the 32. We have to look, the dot has to be in line with the 36. The next dot has to be in line with the 40. That's how we are plotting at the upper limits. And then the last mark is where they actually connect this freehand. It must be a very small shape. That is how we can actually get this mark over here. So therefore, 3 marks for the grounding, for plotting the ogive at the upper limit, and then also the shape of the graph. Now, ladies and gentlemen, this will be a CA. So I want you to write the big. This is a CA mark. Because why? If the learner made a mistake in 1.3.1 and they didn't complete this table over there accurately, in this specific case over here, they didn't complete it accurately, then it means you will make use of this column over here to make sure that we will make use of this data and the upper limits to plot our ogive over here. So right here, this is a consistent accuracy from question 1.3.1. Now, what happens if the candidate plots the lower limits or the mid interval? Then the candidate can still get a mark for grounding at 20,0, and then the candidate can still get a mark for the shape of the graph, but we will not be giving the mark for plotting because the plotting must be at the upper limits. This is what we want to see in this specific case. So there are the 3 marks. 1.4, write down the estimated median of the above data. So in this specific case, the median, we have to get it from our ogive because this is actually group data. So there are quite a few ways in how we're going to award this marks over here. The first one is that the learners will have to be reading from the 16.5. This is where we want to see this. So the 33 divided by 2, that gives me 16.5. So on the graph, there's that little red dotted line. The moment the learner indicates that at 16.5 and they bring it down there, and they didn't write anything else, you can give them a mark on the ogive because they illustrated the skill to actually do this. So let's make sure it's from 16.5. That is where we want to see they are reading the values. And the next one is where we actually want to get the answer of 29.8 yes. Okay. So in this case, we're going to say we can allow anything from 29.4, but we will not be allowing 30. Okay. We're not going to allow 30 at this case. The reason why we don't want to allow 30 at this case because 30 is a part of the minor grid line. So the learner can exactly see where 30 lies. It cannot be that answer over there, but we would say, we would look at 29.8 or anything from 29.4 up to, but excluding 30. We're not going to allow 30 to be given as an answer over here. So what happens if the learner only wrote the answer of 29.8? You will give that learner full marks. What happens if the learner only writes an answer between 29.4 and 30? You will give that learner also full marks because it means the learner might put a ruler, they didn't draw the line, but they actually get it over here. And ladies and gentlemen, just a point of interest. The point of interest is that this is actually, this data is actually complementing the requirements and the characteristics of a normal curve. And the reason for that is because if you look at the average and if you look at the median, it's almost the same. And that's telling us that this data is actually adhering to very close to normal distribution. Now, 1.5. Now, 1.5 It was discovered that the frequency of the H data for K players in the model H. So the reason why I'm reading the question so that we understand how we actually got to our mark allocation, and there was a mistake with the recording of the intervals, and the mistake is corrected, and the frequency of two other intervals are increased. The number of players in the squad remains unchanged. Determine the minimum value of K if the data of the new histogram is symmetrical. So this is actually a problem-solving question, because it's not a question that has been seen before, and they have to think about it creatively. Now, the first mark is where the learner identify those intervals that were actually recorded incorrectly. And that's the interval 24 to 28 and 32 to 36. Those are the two intervals that we actually recorded incorrectly. Okay, because if you look at those two intervals, that is what's making that the data is not symmetrical yet. Okay, and now we are going to say, but listen, if the frequency of both intervals are increased to 9 players, so if we increase the one interval by 1 and we increase the other interval by 3 players, then it's 9. That's the minimum that we can get to. Okay, and then the data will be symmetrical. But it's not about how many players in each interval. It's about, we are looking at the value of K. We are looking at increasing that specific interval. So therefore K equals 4. So in this case, 3 marks for identifying both the correct intervals. If they say, but listen, let us increase it to 9 players, okay, then that would be the second mark that we can give, but still they have to answer the question. And the question is about what would K be? What would be that increment be? And that would be 4 players. So there are our 3 marks. We also agreed, and that's why it's on the marking guidelines to say, if it's answer only, you also give full marks. Now you can ask us, but how? If you look at the histogram, being creatively, you can see, but listen, if I increase this by 1, I increase this by 3, it's symmetrical, so it must be 4. Therefore, we allow the answer of full marks for if the only right K equals 4, because there's no other way they could have guessed it, but actually doing it over there. So ladies and gentlemen, this is concluding question 1. And remember, question 1 is where we really want our learners to get their marks. So let us make sure, don't let us focus on what is wrong. Let us try to look for that what is correct. But just to make sure it's wrapped up nicely, 1.2 can be a CA from 1.1. And then also, we need to understand that 1.3.2 can be a CA from 1.3.1. Also, 1.4 is a CA from 1.3.2, because you need a graph in 1.3.2 to get an answer of 1.4. So let us make sure that we make use of our consistent accuracy. 1.5 is independent of the other questions, so therefore there will be no CA over there. We're going over to question 2. Now, if we look at question 2, at the specific case over here, for question 2, 2.1 is about they need to find the equation. We are dealing with regression over here. So they want to determine the equation of the least squares regression line. So ladies and gentlemen, once again, this is not too difficult to do this, but I'm making use of the calculator. Now, I can also tell you, with a question like this, if they have to put everything into the calculator first for the first time, we would regard this as a level 2 question. The reason why we regard it as a level 2 question is because there's a little bit of work that's involved over here. It's procedures. They have to recall certain steps to be able to do it. But if we ask after that, let's say in 2.2, we ask something about the correlation coefficient, that would have been a level 1, because the data was already captured within the calculator. So 2.1, therefore, more than just 1 mark that we're going to give over there. The first one is if they put down the value of A, they can also put a capital A, it's fine. The second mark is if they give you the value of B. And then the last mark is if they give it to you in the equation form. Now, I know with regression lines, we want to be very pedantic. We want to see y hat and not only y. But in this case, if they omitted the y hat, you still give the third mark because these are lower order questions. We want them to have access to our specific marks over there. If it's answer only, it's full marks because the learner can put it down on his question paper. He's got an A, he's got a B, and they put down the equation immediately as 10.85 plus 0.9x. And then that means over there that the learner will get full marks immediately, 3 marks. Now, but if A and B are swapped, okay, so what happens if A and B are swapped? If the learner only wrote the equation, and you can see they wrote it as y hat equals 0.9 plus 10,85x. So they swapped it. You give them 1 out of 3. That is what we can give them. Okay. The reason why we can justify the 1 out of 3, they had the A, they had the B. From consistent accuracy, they made use of that. Okay. So also let us just focus on that. So there are the marks allocation in that specific question. Madising KC, you've got a question you would like to ask? Just unmute yourself.
Good afternoon, colleagues.
Good afternoon.
Can you hear me, sir?
I can hear you.
Okay, hi.
Yes.
What if a learner just wrote the values, didn't indicate which one belongs to A, which one belongs to B, and the learner also did not write the equation?
So it means, okay, so I just want to make sure the learner just wrote 10.85. The learner just wrote 0.9. They didn't say A equals B equals. And then
Yes, sir. And then they also didn't write the equation. They just wrote those values and left them like that.
Okay, so in this case, this is a very beautiful question because many people might think about it. Marison, I would say in this case, if the 10.85 was written first, and the 10 and then 0.9 was written secondly, we will give the 2 marks. Okay, we would see it as if the learners made the first one is A, the second one is B. But now remember, we don't want the learner to force us to think. Okay, so the 10.85 is written first. If the 0. Someone is not muted, please. So in that case, I would give the 2 marks. If they did it the other way, I don't know what is this. Okay, now recording. Well, someone asked to record it over there. But if they did it the other way, they write 0.90 and they write 10.85 and they didn't put the equation, then it means at that specific case, it's very difficult to give them any marks over there because they're just putting down things. That's what they are doing. Seppo, you want to ask a question? Seppo, just unmute yourself, please. You are muted, but I can't hear you.
Afternoon, sir.
Good afternoon, ma'am.
Yeah, it's Memagoro here. What if a learner wrote the correct value of A and the wrong value of B? Do we see A on the equation?
Yes, ma'am. We always see A on the equation. If they got the correct value of A, it's 1 mark. Now they made a mistake at B, they don't get a mark for B. But now they substituted it in the correct manner.
He or she will be allocated 2 marks.
They will be allocated 2 out of 3 marks.
Yeah, because the value of B will be wrong.
Yeah, that's right.
Thank you.
Okay,
Thank you, sir.
100%. Okay, Madison?
What if both values of A and B are wrong, but substituted them correctly in the equation?
Okay, so if they write down A and the value is wrong, they write B, the value is wrong. No. But now, according to them, it's the correct values. Then they substitute it into the equation. You give them 1 out of 3 marks. Okay, but if they only write down an answer and none of those values it's 0 out of 3 because the learner exposed themselves. It didn't show us where it comes from. So it can be that the learner can write A equals 20, B equals 0.5, so it's wrong and wrong. But now they put Y hat equals 20 plus 0.5x. Then we give them 1 out of 3 marks over there. Okay, that is what we call consistent accuracy, and that's what we need to apply over here. So actually, two beautiful questions asked over here, and I really hope that this actually gave some clarity to many of you. Now at 2.2.1, now it's about a prediction. So ladies and gentlemen, this is a CA from 2.1. So you have to put down big CA. CA, consistent accuracy, it means that we can mark with the mistake of 2.1. So in 2.2.1, we would like to see the learner substituting the 46 into the place of X. And if they substitute into the place of X, they get 52.25. So that would be the answer. So we give 1 mark for the substitution and we give 1 mark for the answer. Those are 2 marks. But now remember, you can also do it with the calculator. So with the calculator, it means at regression, at the function, I think it's number 5 of y hat, you will just click on 5, and before the y hat, you will just put a 46, and you will just put press the equal mark on your calculator, and the calculator will display 52.08. So therefore, we can also give the mark over there. The one is coming from substitution. The other one is coming from the calculator. Now, why is there a difference in answer? Because of rounding. Remember, in the first one, we rounded the values. With the calculator, it didn't round the values. Now, what happens if the learner had a wrong equation in 2.1? So let's say the learner had y hat equals 20 plus 0.5x. Now, in 2.2.1, if they make use of the equation in 2.1, and they say, for example, 20 plus 0.5 multiplied by 46, you give them the mark for the equation, and you follow up on that answer, you give them the second mark. They can get 2 out of 2 over there. It's consistent accuracy. We're allowed to do it like that over there. So please make sure that with 2.2.1, we do follow up from 2.1. It's very, very, very important over there. Now, what can also happen here is, what if the learner decides to substitute the 46 in the space of the y? That becomes a breakdown. That is nonsense. It means that learner doesn't know what to do. So if the learner is substituting the 46 into the space of the y over there, then it means we're not going to look at anything over there. It's a thinking error. It's a mistake, and we don't give marks for mistake. Okay. Now at 2.2.2, we want the correlation coefficient over there. So the question was actually, is the answer in 2.2.1 a good indication of the expected final examination result? So we're asking the learner to evaluate and analyze the question over here. Now our first mark would be for the yes. Okay, so that is what we want to see. Yes, it is. Why is it? Because there is a very strong correlation. That is what we want to see over there. So the first mark would be for yes, and then the second mark would be for very strong. That is where we will give the mark. Okay, but also I would say instead of the very strong, if they put the R equals 0.94 over there, you can give the mark for the 0.94, because many learners, they will write the 0.94 and they would say yes, because they know 0.94 is a very strong correlation. But ladies and gentlemen, please ask your learners, they need to put down the very strong over here. The very strong is represented by the 0.94. So there are our 2 marks over there. 2.3, the only possible answer over there is B. That's the only one that we can work with. So the reason why, because the point that always lies on the line of best fit is the mean value of X and the mean value of Y. So therefore we had to find the average of Y, and therefore it's only B. It cannot be anything else. Now I'm just looking at Mom now. She's just telling us something over here. Okay, so the question was raised over here. What if the learner only wrote strong, and if the learner only Afrikaans wrote star? in this specific case, we would like to see the very strong. Am I right over here? Because remember, we are asking, if you go back to the question, what was the aim of the question? The question was, is it a good indication? And to be a good indication, it must be a very strong correlation. But once again, my prediction is that many learners are going to put down the 0.94, and that immediately represents very strong. That is how we can look at that. Okay, ladies and gentlemen, that's question 2, question 2, and that's 8 marks that we've got over here. If we go over to question number 3. At question number 3, we've got over there, it's our analytical geometry. Now, I can tell you something with analytical geometry, plenty of CA marks. Plenty of CA marks because the one question actually builds to the another question over there. So therefore, we want to make sure that we can make sure of the CAs that we can use over there. Now, question 3.1. If we look at 3.1.1, 3.1.1, we want the coordinates of f. It's the midpoint. So therefore, we give a mark for the x value and we give a mark for the y value. That's what we want to see over there. We want the x value and we want to see the y value over there. Okay, so ladies and gentlemen, there are our 2 marks for that specific question over there. It's a level 1 question because we just plugged it into the formula that comes from our formula sheet. 3.1.2. If we look over there, I just want to check something. Yes, some people can argue, but this value must be 0 because it's the y-intercept. Remember, never in the question paper did we say that f is the y-intercept of the line AB. So therefore, that 0 that we want to see over there, that can only come from calculation. But once again, if they write 0.5 without any calculation, you give the marks. That is what we want to see, because this is where learners should have access to marks over here. Now, 3.1.2, the gradient of df. For the gradient of df, our first mark goes for substitution. So, for substituting, and now I want to point out to you, ladies and gentlemen, with substitution, we want to see, at the top, we want to see the y values. At the bottom, we want to see the x values. If the learner swaps and they put x over y, that is a breakdown. We're not going to even look at whatever he gets from that. That breaks down the whole of 3.1.2. So we give the first mark for substitution and the second marks go for the 2. Once again, it can be answer only because mentally they can look at a diagram and they can say, but this subtract this over this subtract this, that would give me 2 because of the many zeros involved in there. So 2 marks for that. 3.1.3. We want to find the size of alpha. So what is going to be our first mark? Our first mark would, where they set up the equation to say that tan of alpha equals 2. That would be our first mark. They don't have to put 2. They could say tan of alpha equals the gradient of df. Okay, that would also be sufficient enough. Now, the reason why I didn't put down the T goes for tan of alpha equals 2, because, ladies and gentlemen, 3.1.2 is a CA from 3.1.1. I want you to write it very big there. It's a CA from 3.1.1 because you need the coordinates of f. And if the learner is making use of his coordinate of f from 3.1.1, 3.1.2's answer is going to look different. 3.1.3, our solution is dependent on the gradient of the line of df. So therefore, it means, that's why I didn't say tan of alpha equals 2, because then that's what you will only be giving marks for. We want to see that tan of alpha equals whatever the gradient of df is that the learner got in 3.1.2. So by setting up that relation over there, by drawing that relation, that is where we give the first mark. And then the second mark is going to go for the 63.43. I put down answer. I didn't put down 63.43. If you look over here, I specifically put down the answer. And the reason why I put down answer over there is because if the learner is making use of the data from 3.1.2, he's not going to get 63.43, but still is working correctly with things, and therefore we can award the marks. This is called consistent accuracy. So put down at 3.1.2, CA, 3.1.3, also another CA. 3.2, we want to put down the equation of OB. There's only one answer for that, y equals 2x. So that is our equation over there. We don't just want to see the 2x, we want to see the y equals 2x. Madiseng, you've got another question for us?
Yes, sir. Before we move on, in 3.1.1, what if the learner substitutes correctly but forgets to simplify f is 0:5? And then in 3.1.2, the learner substitutes those coordinates correctly. Are we allowed to award the mark for 3.1.1 in the answer in 3.1.2? Or
So
do
I
we
just
just
want
give
to
one
get you on
mark?
this one. So let's say the learner substituted -3 plus 3 over 2, comma 0.4 plus 6 over 2, but they didn't simplify it.
Yes, sir.
Okay, now
And then
Madiseng,
in 3.1.2,
yeah.
they substitute that 0 and 5.
Okay, but I didn't put down the answer of 2, no.
Yes, sir.
Okay, so now what I'm going to ask you, Madiseng. So in this case, the way I would be looking at this specific question over here, in 3.1.1, if we see the learner put -3 plus 3 over 2 and 4 plus 6 over 2, and we say no, but we're going to give this learner 0 because we wanted to see the 0.5. Now remember, there's also going to be another learner that's not going to have anything written at 3.1.1. And that learner would also be getting 0. So in this case, I would say it's very harsh to say if we don't want to award the marks over there. Okay. So in this specific case, I would give the marks. I would literally give the marks over there because the learner is giving me the coordinate. It's just not giving it in the simplest form. That's for 3.1.1. That is why I would give the 2 marks over there, provided that both the substitutions for the x and the y is done correctly. But now when we go to 3.1.2, now it's substituted. Okay, so therefore it's substituted, then 1 marks go for substitution. But in this case, we would really like to see the value of the gradient because learners know when we talk about gradients, we want to see the value. So I hope that's answering your question. In 3.1.1, if they didn't put it down in simplest form, I will still give it 2 marks. In 3.1.2, I will give the mark for the substitution.
Thank you so much.
Pleasure. Marisa, you've got nice questions, and I think that's also helping our other markers over there because they may also be thinking about the same aspect. 3.1, y equals 2x. We did ask an equation, so we want to see the relation y equals 2x. That's very important. Now, some of you can ask, but why only 1 mark? Because O is the origin of the Cartesian plane. And once it's the origin, we only need to divide the y coordinate with the x coordinate. That would give us then the gradient, which is 2x in this case. 3.3, give a reason why DF is parallel to OP. So now there are 2 ways that we can give the mark. The moment the learner writes down the gradient of DF equals the gradient of OB, you can give the mark. The moment they put in words, lines have the same gradients, okay? Because lines have the same gradients, then that means we will also accept that. They can either put it down mathematically by making use of the gradient symbols, or they can put it in words to say lines have the same gradient. That is what we can do over there. So that's worth 1 mark. So plenty of level 1 marks and questions for this specific question over here. 3.4, it is given that PQRS is a square. So therefore, they cannot make use of the properties of a square in any questions before 3.4 because there's now only where we mention it's a square. And we say that the square has an area of 9x squared. Calculate the coordinates of S. Now, to do this specific question, it means that there will be different stops that the learners will have to make. There will be different steps that they will have to show in order to get to our specific answer over here. Now, the first mark is where the learner indicates to you that QR is the same as PQ or is the same as PS or the same as SR, but they are telling you that the length of the side is actually 3x. So that is where we will give our first mark, because if the area is 9x squared, then it means the sides must be 3x. Now, from there, they can try to get the coordinates of R. Now, how do I get the coordinates of R in the specific place over here? Well, it's by saying 3 minus 3x, because remember, we've got already the value that at qx is 3. If you look at your diagram, it's a square. So we really want to see that 3 minus 3x. And then we know that also over there, if I look at 3 minus 3x, and then also if I look at what would be the coordinates of S in that specific case, so QP is 3x. We've got the coordinates of R. So what is the coordinates of R? It's 3 minus 3x, comma 0.0. And then to find the coordinates of S, and the coordinates of S would be 3 minus 3x, comma 0.3x. So 3 marks just to lead up to the coordinates of S. Now, they're going to make use of the equation. So within the equation, they substitute. When they substitute, they get x equals 2 over 3. So that is worth 4 marks. Now, they're going to substitute again. Where are they going to substitute it? They're going to substitute it into the coordinates of S. That's where they're going to substitute it. And by substituting it, they're going to get the values of 1, comma 0.2. So there are the 6 marks for the first response. Remember, this is a higher order question. So in this specific case, it means that the learners will have to show they're working over here. Now, the other part of this question is also by bringing a little bit of trigonometry. Now, the reason why I put this response secondly is because we believe that the first option is the one that many candidates would actually try to follow, because they would not think about integrating trigonometry into analytical geometry. Now, if we look at our second response, the learner can say, but SR equals 3x. So that SR equals 3x is one of the sides of the square. Then I can say, but the angle of the tan of SQR, okay, so if we look at SQR, if they look at SOR, sorry, the tan of SOR is the tan of the angle, whichever they have for the inclination of the F. So this is also a CA. And then I can say that is SR over OR. And then from that, they get that OR equals 3x over 2. So the second mark would be for OR. Now, from there, what am I going to do? Okay, well, if I look over there, I say 3x over 2 plus 3x equals 3. Okay, so where that is actually basically coming from is they are telling you that the distance of OR plus the distance of one of the sides of the square, that has to be 3. That is where we're actually getting this from, okay? So they're looking at the distance of OQ. They know because the x value there is 3, so that distance must be 3. And from this, they solve x to be 2 over 3. Now they're going to set up the coordinates of S for the first time. And the coordinates of S, according to them, will be 3 minus 3x, and that will be 3x. And then they substitute and they get 1, comma 0.2. So the second response is very consistent in terms of the mark allocation to the first response. Because in the first response, we gave a mark allocation for x equals 2 over 3. We gave a mark for the coordinates of S. We gave a mark for giving the numerical values of the coordinates of S. So therefore, it's only the first two steps over here that will differ from the first 2 steps over there. But you have to do this question on your own to understand how the learners will also go about it. And I believe there can be other alternatives as well, but please share it with us, and then we will gladly assist you. So 6 marks over there for the specific question. And ladies and gentlemen, please tell your learners, because sometimes it feels like some of them are giving up too early in mathematics, normally at the end of the question, yes, there will be a higher order question, but the next question, the next big question, that we will always start with the easy ones as well. So they mustn't just give up. This is the nature of mathematics. Now, at 3.5, we need to prove that EDOS forms a parallelogram. Okay. Now, the most important thing over here is they are going to say that E is the midpoint. Okay. So E is the midpoint. Okay. Of what? If we look over there, E is the midpoint of AO. Okay. And what is the reason that we are looking at that? Because we are looking at the converse of the midpoint theorem. That is what we are actually looking in the specific space over here. Because if you look at a triangle ABO, that line is parallel to that line. That is already the midpoint. So I'm dealing with the converse over here. That's why now E is the midpoint of AO, and it's a converse midpoint theorem, and it's a mark for the statement. That and what is the mark for the statement? The moment I put down E is the midpoint of AO, they can also indicate it on a diagram for you, ladies and gentlemen. They don't need to put in words. If you look in the answer book, if they show on a diagram that AE equals EO, that's an indication that is the midpoint. They can get a mark over there. Now, to find the coordinates of E, well, I make use of my midpoint formula, and the coordinates of E is -3/2, comma 0.2. Now, from this, I can say that ES is parallel to DO. Why can I say? Because the same y coordinates. So if you look at S, what is the y coordinate at S? The y coordinate at S is 2. The y coordinate at E is 2. So if I draw a line from one point to another point, they have the same y coordinates. Those two lines are parallel. But in this case, it's a mark for the statement and the reason. So the statement part where they say it's parallel, and the reason why they say they must indicate the same y values. And then they're going to say that EDOS is a parallelogram, but now we're going to give a mark for the reason, because we ask him to prove that it forms a parallelogram. And the reason would be that both pairs of the opposite sides are parallel. Okay, so there are the 4 marks that we are looking at. The statement to say or showing is the midpoint, 1 mark for finding coordinates of E, a statement reason mark for to say the lines are parallel with the reason, and then also by giving us the reason why this is now actually a parallelogram. Or what also could have happened over here is we could have said, but E is the midpoint of AO. That is a statement mark. It's very consistent with the first response as well. Finding the coordinates of E, okay? So if we find the coordinates of E, it's -3/2. But now, what can the candidate now do? Because we know about a parallelogram, that the diagonals intersect each others, okay? So therefore, they can calculate, and they can say, but listen, if we know, if we calculate the midpoint of, let's say, DS as well, okay? And we want to calculate the the midpoint of EO, they will find it's -3/4, 0.1, and the other one will also be -3,4/1. So therefore, we'll give 1 mark. Now you're going to say, but why only 1 mark for plenty of calculations? The learner decided to make use of a method that requires more work. Because if you look at the first response, there was a very easy way in solving it. Now the learner is making use of diagonals and the midpoints. So therefore, the learner is creating more work, but we only give 1 mark if we see the calculated midpoints of both of the lines. And then once again, the reason would be the converse of the diagonals of a parallelogram. So that would be our 4 marks over here. So colleagues, just once again, please remember that this is the part that we want to see our learners getting marks. So therefore, let us make sure that in analytical, that we look very carefully at whatever they wrote over there. So that was question 3. When we go to question 4, question 4.1, determine the equation of the circle. So to find the equation of the circle, so it was an expanded form. So now we're going to do a little bit of completing the square. So when we look at that specific part over there for completing the square over here, so we're going to end up by having the left side as bracket x minus 2 all squared plus y minus 4 all squared equals 100. So it's 1 mark for the left-hand side and it's 1 mark for the right-hand side. Remember, you don't even need to show all of that steps over there because you can do it mentally. Because to find the left-hand side, I only look at half the value of x, I only look at half of the value of y, and I keep the sign. So it's very easy to say x minus 2 squared plus 1, y minus 4 squared. And on the right-hand side, they could have done it on rough work, on the question paper itself. So therefore, if you see the left-hand side, you see the right-hand side, 1 mark for the left-hand side, 1 mark for the right-hand side. Okay, and there cannot be any CA over here because this was the first question and I had a diagram. 4.2.1, write down the coordinates of P. So when you have to find the coordinates of P, ladies and gentlemen, 4.2.1, I want you to write it big. 4.2.1 is a CA from 4.1. Because remember, in 4.1, if they made a mistake with the signs and they put x plus 2 squared plus y plus 4 squared, now in 4.2.2, they may record P as -2, -4. Now, once again, there's a diagram, so I can't imagine why they want to do it. But, under exams conditions, learners, once they started with something, they follow through with that. So if we were very strict, we could have said, but no, it cannot be negative because the diagram is there. But also you have to look at what the learner did in 4.1. So let us just make sure we make a follow-up, and it's 1 mark for the x, 1 mark for the y. 4.2.2, we want the equation of QR because that is a perpendicular line because the x values are the same. It's the line x equals 10. So level 1 questions, plenty of them over here. So also coming from previous functions. Then 4.3. If I look at 4.3, determine the equation of the tangent QS. So now we are looking at the diagram. We want the equation of the tangent QS. So our first start off is to find the gradient of QP. So to find the gradient of QP, which is the gradient of our radius, they need to substitute correctly. And then they will find that QP equals 3/4. And from there on, they have to find the gradient of QS because it's a reciprocal and it differs in signs. So therefore, the gradient of QS will be -4/3. And then I just put a reason over there. But in analytical geometry, we don't really want to give marks for the geometry reasons. The -4/3, that is 100% acceptable for us. So that would be 3 marks up to there. Now they need to substitute it with the coordinates of 10, point 10. They can't use any other coordinates than 10, point 10 because that's the only coordinates that are known to them. The moment it's substituted, now look, they can either work with y equals mx plus c, or they can work with y minus y1 equals m brackets x minus x1. In both cases, the substitution mark must be given. And then for the final answer by saying y equals -4/3x plus 70/3. That would be the 5th mark that we can give to them. Now, 4.3 is a CA from 4.2.1. Because remember, to get the coordinates or to get a gradient of QP, we need the coordinates of P. So you will have to look at 4.3. What was the coordinate of P that the candidate wrote down? If the candidate wrote down the coordinates of P to be 3, 5, then in 4.3, the learner will be writing 10 minus 5/10 minus 3. And that means we will have to award full marks from there on because it's consistent accuracy. Now the learner gets the second part of QP. Now at QS, to get that mark over there, we really want to see the change in signs, and it must be the reciprocals. Now I can tell you from experience, the majority of learners, and you can ask those markers from the national papers marking the end of the year, the papers in Northwest, the majority of learners, they would put down the gradient of the tangent is negative 3/4. They forget to change it. So in that specific case, they will lose the mark for not stating the correct gradient. But we will CA for substitution, and we'll also CA if they put down the answer correctly. But now to CA, let's say they get everything that, let's say they get the wrong gradient of QS. We can only CA the last 2 marks if the gradient of the radius and the gradient of the tangent, if they have different signs. That is what is very important. They can't put down the gradient of QS is 3/4, and now we want to give them substitution marks. We cannot do that because remember over here we are dealing with a perpendicular line, so there must be a change in sign. That is what's very important over there. That's 4.3. 4.4, calculate the size of RQS. So in this specific case, we're going to look at the tan of angle QS, and that X is of the X-axis. So we're going to use the tan of that angle, and we're going to equate it to -4/3 because that's part of inclination. And then we solve for QSX. QSX is 126.87. That's the first mark. We're not going to give a mark again for linking it because previously in question 3 we gave marks away for linking it. Then what the learner is going to use is they can use the exterior angle of a triangle, or they can make use of angles on a straight line, and then they can work with the interior angles of triangle. Doesn't matter, but they must have a method in which they can link the angle of RQS with the given information they've got over there. And then the last answer would be where RQS equals 36.87. That would be our third mark. But now, ladies and gentlemen, remember 4.4 is a CA from question 4.3 again. Because in 4.3, remember, for the first time, they calculated the gradient of QS. So if they get a gradient there, let's say they got a gradient to be 5/2, then in this case over here, they will link it with 5/2. You're going to get different values, but look at the methods that they are using. Madisek, you've got a question for us?
Yes, sir. What if a learner did the correct method but did not indicate a reason for the method for the second mark?
Okay, so what I'm going to say over here, Madisek, is that because this is analytical geometry, we don't really want to go too much into the reasons of geometry, because geometry will have a section at the end of the question paper. So in this specific case over here, they don't need to put down the reason. You can see whatever they are doing. Sometimes I will indicate it on a diagram. So I would give 3 out of 3 marks over here. If I can say, but listen, they've got that angle, they're linking it up with the 90 and that, and this is the way they're following, I will give the mark over here. Because we didn't say explicitly a mark should go for the reason. And the reason for that is, in analytical geometry, we try not to be so heavy on our reason marks in geometry. Are you satisfied, Maricel?
Thank you, sir. Yes, sir.
Okay, once again, beautiful question. 4.5, calculate the area of triangle PQR. So once again, different ways the learners could have followed over here. I think if they've been revising past papers, they would know that normally it's over here that we include the area rule. So that's why we put it up here first, because that may have been a first option. So the first mark would be, you can't make use of the area rule if we don't have the angle of PQR. So in this case, I see there's another hand up. Let me just quickly deal with the solution, then I will come back to you. So PQR is 53.13. That is our first mark. And once again, as Mariseng asked previously, we're not going to give a mark for radius perpendicular to tangent. We're just going to give a mark for the PQR. That's 53.13. But once again, remember, it's a CA mark from your previous question. Then we're going to say that PQR equals QRP, because that's the angles opposite the equal radius. And from there, I can conclude that QPR equals 73.74 degrees. So that is my second mark, is to find the angle of QPR. So you have to make use of highlighters to highlight the angle PQR, the angle QPR. Those would be our first two marks, and it's only for the values. Now, then the third mark would be where we are substituting in the area rule correctly. So we don't just state the area rule, we are substituting into that area rule correctly. So it's a half times 10 times 10 times the sine of 73.74. Also remember the area rule is dependent on what the learner calculated from QPR. Now, if they calculate something wrong from QPR, and they substitute another angle, but it's coming from QPR, it's a CA mark. And then the fourth mark is for getting the answer of 48 units squared. Okay, so let me just take this question. I only see HiPad X. I don't see a name, sorry. But you can ask your question, sir or ma'am.
Please, I want to find out 4.4. Is there any other method that can be used to find the angle?
Okay, so the other method that we can try to find that angle of RQS would have been, instead of working with the exterior angle of a triangle, they could have worked with angles on a straight line. And then once you've got an angle on a straight line, they can try to find the angle of QXO, and then they can work with the sums of the angles of the interior triangle. So that's the only one I'm looking at now. I don't know if you've got an alternative for us.
Fortunately, the learner that was applying the cosine rule over here.
If the learner wanted to apply the cosine rule over there.
Yes, please.
Okay, if the learner wanted to apply the cosine rule in finding RQS, then the learner needed the distance of QR, which I don't know the learner doesn't have the value of t over there. So maybe they substituted, they can get the distance, they can get the length of QR, but now also they need to find the length of QS, which they can do by calculating the x-intercept of the tangent. But now they will also need the distance of RS. And once again, to find the distance of RS, you must have the coordinates of R, which my reasoning is, if they want to make use of the cosine rule in that triangle over there will be a lot of writing that they will do over there. And that's why in that case, we will not put it on the marking guidelines, because this is a way that we don't think the learners will actually go. But they can make use of the cosine rule, but they will have to apply the distance rule at least 2 times, because QR is easy to see, it's a vertical line, and then they will have to apply it. So that's why we say this is a marking guideline. So if you are of the opinion that the learner did it correctly, then we would really like to see that those marks are awarded to that specific learner over there. Now, the question can be, where will you allocate the marks? Now, always try to work backwards. The 1 mark would definitely go for RQS. Then I would say the other mark would go for substituting into the cosine rule, which is actually very important. And then the first mark would need to go for finding distances of all 3 of those lines. So that would be the 3 marks that we can give over there. But something like that, we're not going to put it on a marking guideline, because this is this is not a method we want the learners to actually follow. Okay, are you satisfied with that, sir? But you can give the marks.
I'm happy.
Okay.
Yeah.
Thank you.
Thank you.
4.5, the second option over there that we can look at is once again for finding 53.13. Now the learner is going to say that Q and R are symmetrically about the line y equals 4. Okay, so they're going to say that Q and R is symmetrically around the line y equals 4. Because remember, if you look at the center of the circle, therefore the y value is 4. And we know that Q and R is going to be symmetrical about that specific line over there. And from there, we can solve that t equals -2, and therefore the length of QR equals 12. Now, to go back to our previous question, so in this case, finding the distance of QR, we didn't need the distance formula. But to find the other lengths of the RS and QS, you will need the distance formula. And now, for using this, we can substitute the 10, the 12, and the 53.13 in our area rule, and then we get an answer of 48 units squared. So that would be if the learners try to look at it in a different way, to say, but this is how we actually want to do it. So, and that's how we're actually going to deal with it. Okay. So, ladies and gentlemen, we spent a little bit of time at this question over here, but questions, the relevant questions were asked. I just want to make sure, Mr. iPad X, your hand is still up. Do you have a new question for us, or did you just forget to lower your hand over there? Okay, I think we can move on. Now, 4.6. When you look at 4.6, a beautiful question, level 4 question over there. So if you look at a question, a function h is formed by restricting the range of the circle to y greater or equal to 4. So we are restricting the range of the circle to say, but now we're only going to look at those values greater or equal to 4. That is what we want to look at. Now, if we look over there, we have to find the value of the sigma notation of x equals 3 up to 12 of the function of hx. Okay, now where are we going to give our first mark? Now, this is a problem-solving question. Now, ladies and gentlemen, this is all about the symmetry of our circle. If we look at our circle, and we are saying the x value is from -8 up to the x value of 2. If we add up all those function values, it's exactly the same as the function values from 2 adding up to 12. So that would be our first mark that we are giving, that they see the symmetry of this circle over here. The second mark would go for giving the function value at 2, which is 14, because we're going to need that. Now, let us look at our third mark. So, to go from x equals 3 up to 12, okay, it's the same as when we started from 2 and we went up to 12, and we are just subtracting the function value at 2. So that was something they needed to see. So that would be the third mark. If they indicated, and over here it's very difficult to put it in words, they will have to put it into symbols. You really want to see, instead of going from 3 to 12, we could have gone from 2 to 12, and we could only subtract the function value at 2. And now the moment we do this, we can say, but listen, this part we already calculated, it's k, and that value is 14, so let's subtract the 2 from each other, and there's our 4 marks. So this is a level 4 question, and remember, 15% of the question papers are allowed to have these unseen sort of questions, but nothing the learners used over here was something they didn't use before. But there are the 4 marks. I doubt whether you could do it in an alternative manner, but this is the manner that maybe we think the majority of learners that did attempt it, that they will also then follow this manner over here. Now, if we go over to question 5. Question 5, if we look at question 5 over here. Question 5, all about our trigonometry graph over here. And now, ladies and gentlemen, also because memo discussion is also where you can reflect on teaching, it's always important to know when we ask a question about graphs, we would really like to see learners using the graphs to solve the problem. We really want to minimize all those procedures. We really want them to make use of the graphs. Now, our first question, 5.1, we want them to write down the value of A, and it's over there, A equals 1, and that is 1 mark over there. Level 1 question, 1 mark. 5.1.2, we wanted the learners to find the coordinates of Q over there. So the coordinates of Q over there, it is symmetrical because we didn't made use of any horizontal shifts over there. And this is the beautiful part of the sign graph, especially when we look at the first part on the positive, first part on negative. It's very symmetrical. If we can only reflect it also a little bit. And so in this case, if we look at P and we look at Q over there, we know that the readings will be the same, but the values will change in sign. So therefore, Q, it will be 68.53, and the Y value will become 0.68. So there's the mark for X, and there's the mark for Y. We can't give any CA marks over here because the information is on the graph. They have to make use of these values over here. 5.1.3, write down the X values of the turning points of H if H of X equals f of x plus 30. So in this specific case, the graph is translated. Okay, the graph is translated in which manner? Well, it's been moved down to it's been taken to the left. So if I take it to the left by 30 degrees, this turning point will become negative 75, and then the other turning point will become 15 degrees. So therefore, the two answers will be negative 75 or x equals 15 degrees. Colleagues, I'm just going to pause here for a moment because yeah, some questions been asked here. Sorry, I did miss on this one. I just quickly want to stop here. 1.4, if a learner set position at 0.5, 33 plus 1, then 30 must be correct. Please clarify. Okay, so sorry, I'm just going to stop here. If we can go back to 1.4, the question was raised by one of our markers over here. So if the learner said the position will be at 0.5 times 33 plus 1, so that would be at position 17. And then I will get an answer of 30. So to say over here, when we work with group data, we don't want to work with n plus 1. We only want to work with n. So also to put this in greater context for you, where this whole thing about n and n plus 1 comes from, it's a general agreement within statistics. If we work with a sample space greater than 30 or greater, we no longer make use of n plus 1. We only work with n. If we work with a sample space less than 30, that's actually we make use of the n plus 1. So unfortunate 1.4, in this specific case, because it's an ogive, the learner could not have worked with the position 0.5 multiply 33 plus 1 because it's ogive. Only work with the 33, and because of 16.5, they would know it's less than 30. So once again, as I say, 1.4, it's towards the end of the question, so therefore we want to see a little bit more of accuracy. There's another question. What if the learner substituted 46 correctly, but got the calculated answer? Okay, so I think what the marker is saying, or the educator is asking, the candidate substituted 46, and then the candidate got 52.08. I would give full marks, okay? Because what's happening over here is the candidate is substituting, and then the candidate is all of a sudden remembers, but listen, I can also check it with the calculators. In that case, I would give it 2 marks. In 3.2, if the learner only wrote the gradient, is full marks allocated? We're just looking over here at, is it 3.2? If the learner only wrote the gradient. Okay, 3.2 is about an equation. So we wanted to see y equals 2x. But in 3.1.2, if they only wrote the gradient, there would have been the full marks. Then Okay, this one of Madising we already dealt with. There's another question. What if the learner solve the formula of the gradient instead of change in y, of change in, she has change in x? Okay, I think that one we also alluded. We want to see the change of y over the change of x. If the change of x over the change of y, it's a breakdown. That is what it then becomes over here. Okay, so ladies and gentlemen, I think I've looked at the at our questions over here. So my apologies. My apology for not looking at that earlier. So 5.1.3, there are my two answers. Okay. They don't have to say x equals negative 75. If you see, they put down negative 75 and they put down 15 degrees, you give the 2 marks. Okay. Because it's lower order questions, we want them to have access to those marks. 5.1.4, the values of x, where g of x is between 0.68 and less than 1. So you have to look at the graph. So what would be the values of x? So the values of x would be from negative 68.53 that we will be looking at, and that's excluded. And then it will go up to 90 degrees, where the 90 degrees is actually included. Now, how are we going to mark this? First, look at the critical values. Always look inside of the bracket. If the values inside of the bracket, if those values are correct, give the first mark, and then you look at the proper notation. And the proper notation would be to have the correct closed brackets and the correct open brackets. So that second mark would be for perfect notation. That is what's very important. But now, colleagues, please, we don't give 1 mark for the notation if our critical values are not correct. So learner cannot write open bracket 30 degrees, comma 0.50 degrees, close bracket. No, we only give the notation mark if our critical values are correct. And there are no CAs over here because everything is under graph. Okay. Now, 5.1.5, the value of m, where f of x plus m equals negative cos of 2x, m has to be negative 45 degrees because we are looking at a shift over there, and then it must become a co-function. So if m equals negative 45 degrees. 5.1.6, what is the value of b? The value of b is a half that we have over there. So the value of b is a half. And once again, many people, because if you look at the original graph, the value of 1 should be 45, but now it's at 90 degrees. And we always look at what we have with relation to the original graph. So b equals a half. 5.2, that was a level 4 question, a little bit of creative thinking. So we're asking you for which values of x in the given interval will that be greater than 0? The moment you saw the square root, you knew that the square root has to be positive. And for the square root to be positive, x must be positive. So I can only be focusing on a positive x-axis. Now I'm looking inside of the square root, and I want to know for which values will gx minus fx be positive. And if you look at your graph, it can be only those function values to the right of the intersection of q. And what is the x values to the right of the intersection of q? It's 68.53 up to 90 degrees. So those are the values that we will accept over there. So, and it's 3, how many marks? Is it 3 or 2 marks? Sorry. It's 2 marks, sorry. Yeah, I'm still working with the old memo over there. And those marks over there, that's 2 marks over there. So in this specific case over here, what we can say, you are going to give, yeah, sorry, just make sure over there, colleagues, I just want to ignore whatever you see over here. That's still the old one over here. So on your memo, it should be showing accuracy. And now, why can we say accuracy? The reason why we are saying accuracy in this specific case is because it's a higher order question. That is why we're not going to look at the 68.53 and the 90 and then at the brackets. We want it to be perfect for those 2 marks over there because it's a higher order question. Ladies and gentlemen, our 12 marks for that specific question that we've got over there. I just want to see if some people want to be admitted. Okay, just look at chats that are that also about 5.2 mark allocation. It's 2 marks. I did talk about it. So you have to look at the marking guidelines you've got. And 5.1.4, Little Nolo is asking if the learner writes x greater than negative 68.53. Let me just look at 5.1.4. Okay, so in this specific case over here, we're not going to accept that as our final answer, because by saying x equals negative 68.53, the learner is not stopping the solution. So in this case, the learner is saying that all of the values greater than negative 6.853 would be accepted, but we have to stop it at 90 degrees. Okay, so in this specific case, once again, I would say you have to see this negative 68.53 and the 90 degrees. That must be there for a mark. And then you look at the notation. Okay. Now let us go on to the next one. It's question 6. Just want to check my guideline here as well. Right, ladies and gentlemen, when we look at question 6 over here, 6.1.1, the first mark is for applying the Pythagoras by saying x squared plus 24 squared equals 25 squared, and by saying x equals negative 7. That's our 2 marks. Okay, so that is where we can get it. Also, what we can say is the learner can also indicate it on a diagram for you. So also please look at the diagram. If the learner only said x equals negative 7, full marks, because you can also do it mentally, because the learner can just say 25 squared minus 24 squared, and it must be negative according to the diagram. So the moment you say x equals negative 7, please give the mark to that learner over there. 6.1.2, we have to simplify that. We have to reduce that. So the first mark is for negative tan of theta. That is where we're going to give our mark. And then our answer is 24/7. So first mark for negative tan theta, and then the second mark is for the 24/7. So they have to substitute, but they have to simplify it in this specific case. Now, once again, I'm telling you, I didn't give the mark to 24/7. I give the mark to the answer. The reason why, it's a CA from 6.1.1, because if they calculated x equals negative 5 in the first question over there, you're going to get an answer here of 24/5. So please make use of a CA over here. Answer only. What if the learner only wrote 24/7? Okay. In this case, we would also give the 2 marks. Let me explain to you why. To say the tan of 360 minus theta, there's nothing difficult about it. It's something they've been dealing with for 2 years. So they know it's going to be negative tan theta. They know it in their head. And now they're looking at a diagram and they're saying, but listen, if I look at a diagram, from where can I find the ratios of tan theta? Then they will find it is 24/7 if they've got it like that. So therefore, answer only, we will also accept that and we can justify it. 6.1.3, calculate the size of PO2. The first one, I'm going to say tan of theta equals 24/7. So they're going to find our reference angle in the triangle to be 73.74 degrees. That will be the angle of theta inside of our triangle over there. But now to find POT, they're going to say it's 180 minus 73.74, and that will give us 160.26. That would be our second mark. So our first mark would be for the acute angle of 73.74, and our second mark would be for them subtracting it from the 180. Once again, ladies and gentlemen, 6.1.3 is a CA from 6.1.2. That is very important. Or from all the previous questions, you also have to look at that. 6.2.1, so without the use of a calculator. So let's look what's going to happen over here. That cos of 120 that will be rewritten as 180 minus 60. The 405 will be rewritten as 360 plus 45. And that 110 will be rewritten as 90 plus 20. Now, in this specific case, we're not going to give a mark for the rewriting of it. The moment you see it becomes negative cos of 60, you give a mark. The moment you see the tan of 45, positive tan of 45, you give a mark, and you give a mark for the negative sign of 20. For those three, we're going to give a mark. And then the last one is our answer that we have to put down there. So that would be our last point over there of negative half. Now, the reason why I say answer, because sometimes they can make a mistake. They can say it becomes positive cos 60. And then they're going to lose the mark because it's not negative cos 60. They can still get a tan 45. They can still get a mark for the negative sign 20. But now, because of the positive, their values, their answer can start to change. And therefore, they can still get 3 out of the 4 marks. Okay. So they cannot, if they only put down answer only, in this case, you're not going to give any marks. And the reason for that is, ladies and gentlemen, because if it's answer only, they use the calculator. This is what they've done. Mariseng, you've got another question for us?
Yes, sir. I'm sorry to take us back a bit. In 6.1.3, do we penalize learners if they rounded off incorrectly?
Okay, what would you regard as incorrectly?
For instance, the 7.3, I mean 73,739. So instead of writing 7.4, they wrote 7.3 in the decimal.
No, can I just say, I hear exactly what you would say. Mariseng, the only time I will literally penalize them in 6.1.3 is when they take it to the nearest integer. If they want to make it 74. You know, if they want to say the whole angle is 74. 73.39, I will accept. I will accept that. Remember, there's a lower order question. We really want our learners to get marks there. Even if they said 73 point, I don't really want to go into that. If they say 73.7, I would also accept because they're just running down to the other way. But I will, the moment I put it at 74 degrees, only 74 degrees, I will not give them a mark for theta, but then I will CA it to POT. But 73.739, 73.75, with those things we can allow. Okay. So don't let us try to be too harsh on them over there. Mr. iPad? Yes, sir. Your hand is up. iPad X. Okay, let us go on. 6.2.2. So once again, a little bit of algebra. So the first mark would be for 2 cos squared 15 minus 1. So they saw the difference of square pattern. They worked with it. They got a 2 cos squared 15 degrees minus 1. That's our first mark. Now, where is our second mark that we want to give to the learners over here? Someone's speaker is, I don't know. Okay. Mr. iPad, I can see your hand is up, but I don't hear anything from your side. But at the moment it's sorted, you can just unmute yourself and ask.
I want to find out 6.2.1.
At 6.2. Yeah.
Yeah. I'm trying to find out if the cos 120 is now expressed as 90 plus 30, and then they end up getting negative sine 30. Do they get a full mark?
Which question? Sorry, I just switched it for a moment. At question
6.2.
6.2.1.
Yes, please.
And now your question what?
I'm asking
okay, so instead of cos of 60, yeah,
cos 120 is expressed as negative sine 30 degrees. Do they get a full mark?
You can give them perfectly full marks because cos of 60 equals the sine of 30 co-functions. Yes, you can. 100%.
All right, thanks.
Okay, so
All right.
So at 6.2, then I don't know if sound is coming from my side now. At 6.2.2, the second part is where they got a negative sine 2x and they write it as negative 2 sine x cos of x. That's our second mark. Then for the cos of 30. So the cos of 30, where does the cos of 30 comes from? It comes from the double angle of 2 cos squared 15 minus 1. That's a cos of 30 degrees. And now, for the answer of negative root 3 over 4, that would be our fourth mark that we can get over there. So, ladies and gentlemen, this question really did test it. The double angle for cos and the double angle for sine, and also a little bit of reduction that we could have used over here. So there are our 4 marks. It's very important with a highlighter. Highlight the specific places you want to give those marks so that we can give the learners those specific marks over there. Then at 6.3, if I look at question 6.3, if the sine of x plus y multiplies the cos of x plus y equals 2, express the following in terms of t. Okay, and now we are given the specific part over here. Now we're going to do a little bit of reduction. So we've got a cos of 90 minus 2y. That becomes the sine of 2y. And we're going to give a mark for the sine of 2y. Then also here, we look at the cos of 360 plus 2y. That becomes only the cos of 2y. So that's another mark once again. So even within this difficult question, there are 2 places where the learners actually get level 1 questions that we can give them marks over here. So, so let us just make sure they get the marks over here. I just want to check. Someone's hand is up. It shows some. Yes, sir. How are you?
Fine, and you?
Very well, thank you. What's your question? How can we assist?
Yes, it's Kalapa from Kopanye here. I'm on 6.2.2.
Yes.
My question is, suppose a learner does not show 2 cos squared 15 degrees minus 1 and all those steps.
Yes.
But continues with other ways and eventually gets negative 3 square root of 3 over 4, correct?
Okay, so what I'm trying to think over here is, if they didn't make use of the difference of squares, and I wanted to keep the cos of 15, the only way they could have worked is by rewriting the cos of 15 as the cos of 45 minus 30 degrees. So that means they will have to work with compound angles. The moment they start working with compound angles, it means it's going to become a very tedious and very long and lengthy process. So the moment they've illustrated here that they're going to write that cos of 15 in terms of the cos of 45 minus 30, and then they start working with compound angles, then I would say from there you can award marks. But now, the other thing is that we need to think about is, what are they going to do with the sine of negative 2x? So we've got about 2 ways here, sir. They could have written the 4 sine x cos x. They could have written that as 2 sine 2x. So they could have changed that one. And then the sine of 2x and the sine of 2x still could have cancelled. So that's still within the correct way they are doing this over here. But as I say, there is another way. But then you have to work with the cos of 50. But then it becomes a very lengthy process. And then you can just follow what the learners are doing. The reason why we didn't include that one on the marking guideline is because remember, whatever we send out in the province, that is what we would like the teachers to make use of their teaching practices. So we'd really like them to see the shortcut over here. So yes, indeed, they can make use of other ways, but then they would have had to make use of a compound angle. If they didn't make use of any compound angles, then it will be very difficult to give them many marks out of 4. Are we sorted on that one?
I'm covered.
Okay. Thanks a lot, sir. And thanks for also mentioning that, because especially with the cost of 15, and it's like, you know, if you don't see the shortcut, you can make use of another method. but then that's really going to disadvantage the learners as well. So we need to show our learners that they need to be, open and alerted to the shorter ways. But thank you, sir, for raising that. Okay, 6.3. I just want, there's still some members who wants to get in. I'm just admitting them. Okay, 6.3. So the sine of 2y, the cos of 2y. Now, the moment we've done that, we're going into reverse gear. And we want to see where they are applying it as a compound angle. The only way you can see that they are making use of a compound angle is by having the 4 bracket sine, and they are adding those two angles, because this is the compound angle for sine. So you want to see that specific angle over there. So that would be the third mark. Now what's going to happen is, I'm going to take out the 2 commonly. If I take it out commonly, I get a sine of 2 brackets y plus x. So in this specific case, we really want to see that they are starting to make use of a double angle. But now what we would like to see is where they express that as a double angle by writing it as 8 sine y plus x cos y plus x. That is what we really want to see. So not only for taking out the 2, but I have to put down the double angle identity, which can be 4 times 2 sine y plus x cos y plus x, or 8 sine y plus x cos y plus x. So that would be our mark. Okay. And then from there on, okay, we can say now where they are substituting. So because we know that what we can substitute with, and we get an answer of 8t. So that would be our 5 marks. Sine of 2a, cos of 2a, by writing as a compound angle, by writing that as a double angle, and then by getting the answer of 8t. So that would be the 5 marks we can get over there. And once again, ladies and gentlemen, as we pointed out in the beginning, remember, these are marking guidelines. So learners may have used another method that we don't really see right now. And then as long as they work correctly, mathematically correctly, then we can still award the marks. 6.4.1. It's given that sine of squared x plus cos squared x plus tan squared x. And now we have to prove that everything equals 1 over cos squared of x. Now, the first mark would be if the candidates pick up that sine squared x plus cos squared x equals 1. So that's worth a 1 mark. The second mark is where they are rewriting tan of x in terms of sine x over cos x. So tan squared x becomes sine squared x over cos squared x. That is our third mark. Our second mark, sorry. Our third mark is by simplifying, by saying this becomes cos squared x plus sine squared x over cos squared x. That is our third mark. That we want to see. And we're not going to give a mark for 1 over cos squared x because that's what I had to prove. So there's our mark allocation for 6.4.1. It's for identifying the square identity, identifying the ratio identity of tan squared x, and also by simplifying and writing it as a single fraction. That's 3 marks over there. Now, if we look at our next one, the question is 6.4.2. It says over there that Ati, a grade 12 learner, argues that the square root of sine squared x plus cos squared x plus tan squared x cannot equal 1 over cos x. Okay, so and now we are looking whether the learner is saying that the argument is correct or not correct, but the learner will have to motivate it. Now, first of all, if you look at that square root can never ever have a negative number. So the moment they are illustrating to you that the square root cannot have a negative number, by substituting any value between 180 up to 270, if they substitute into cos of x, they're going to get a negative value. So the first mark is Ati is correct, or the learner is correct, and then the second mark is for actually illustrating it to you. Now the reason why I put it like this, because you cannot put down an answer if you haven't proved anything yet. So that's why I first put down the statement, and then I put down whether it was correct or not correct. But I believe many learners will be doing the other way around. So it doesn't matter in which way they did it. If you see the correct, you give a mark. And if they put down, if they tell you, but the square root of that cannot equal a negative number. And ladies and gentlemen, maybe this is also a misconception that many people have over there. By agreement, the square root of 25, I'm telling you, it's 5. But if we say x squared equals 25, because of that quadratic equation that we're actually going to solve by making use of square roots, that is where the plus or minus come from. And that's sometimes where learners actually have a little bit of a misconception. But in this case, this is the statement and this is the answer. And that is how they actually had to do with that. Also, yes, ma'am, now you want to say something?
Yeah, good afternoon, ladies and gentlemen. I want to know, will we allocate some marks only for the answer that Ati is correct without any statement? How are we going to allocate some marks? Are we going to allocate some marks? Mr. Smit, how are you feeling?
Okay, so yeah, depending on how we are looking at this question, I would say 6.4.2. It's a little bit of a higher order thinking, not that higher order, because it's not like they actually have to engineer the solution from. It's actually in front of their eyes. Colleagues, what my suggestion would be in this case, I would say, if they say he is correct, let us give the mark, and then to prove it, we give the other mark. Okay, because also, ma'am, now I'm just looking at this. If a learner is looking at whatever is typed at 6.4.2, and they immediately say, but listen, 180 over 270, if I just substitute over there, it's going to be negative on that other side over there. And therefore, I'm going to say it's correct. And they forget to put the motivation because we first ask if it's correct or not, and then we ask to motivate. So in this case, I would say, let us accept the correct, independent or irrespective whether they proved it or not, because if they didn't prove it or they didn't put down the correct statement, they will not get full marks. So I'm happy to go with 50% there.
Yes,
Okay.
I agree.
Okay, thank you. I just want to say, I just want to admit. Right, 6.5. So 6.5, so show without using a calculator, the sine of x equals 1 over root 2. So once again, ladies and gentlemen, if you've got a candidate that substituted x with 1 over root 2, and they say left-hand side equals right-hand side, remember, that's verification. That is not solving it, and it's not showing it, and therefore you're not going to award any marks. Okay, so you need to tell your learners there's a difference between verification, verifying a value, and solving a value and showing a value. Now, in this specific case over here, our first mark would be where the cos of 2x is written as 1 minus 2 sine squared x. So they can either write it in the exponent form, or they can just put down cos 2x equals 1 minus 2 sine squared x. It means that they have that skill. We can give them that specific mark over there. Now what's going to happen is a little bit of simplification is going to take place over here. Okay, so if I look at my little bit of simplification, it is I'm looking at a 10 over the 2 to the power 2 sine squared x. So it's where that negative exponent was written as a positive. So the moment you see 10 over 2 to the power 2 sine squared of x, we're going to give our second mark. Now, what are we going to do now from over here? Okay, we are going to write it in a standard form. So to write it in a standard form, I need to multiply straight through with it. So they can immediately write down the standard form. If I multiply it with 2 to the power 2 sine squared of x, then we're going to give a mark for our factors. So our factors needs to be perfect over there. Now, I think my prediction is that some of the learners may be making use of a K method. Yeah, I think that's what they will do. They would say, but make this equals to K. It's perfect. They can do it. But then at the end, they have to link it back. then we can accept it. So there would be factors. And now that immediately they're going to tell you, but 2 to the power 2 sine squared x cannot equal negative, because 2 to the power anything can never be negative. So if they put down, they don't have to put down that not equals -5. They could have also rejected the solution. They could have said it's not applicable. There are other ways how they could actually have done this. And now they work with the other solution. In the other solution, they get sine squared x equals a half, and that would be our 6th mark. Because by taking the square roots on both sides, we get what the answer basically asks, okay? And this is what we can get over here. There's no need for that plus minus to be there. The only reason why I put a plus minus there is because many people would say it's a plus minus solution. But now, if you go back, x is a value between 0 to 90 degrees. So therefore, in this specific case, that is sufficient enough to say, but we stop at sine squared x equals a half, and that is where we want to go with this specific solution. So there are the 6 marks for this specific problem. It's for identifying or rewriting the double angle of cos as 1 minus 2 sine squared x. It's by splitting up the exponents and then writing it as 10 over 2 to the power 2 sine squared x. It's getting the standard form. It's for getting by getting our factors, and then also by saying we have to disqualify one of our solutions. It cannot be equal to -5, and then also it equals a half. And that is where we're going to stop, because we're not going to even mark for this last part, because that was actually asked over there. Okay. Yeah, Derek, you are all over my notes over here. Okay. Question 7. Let's look at question 7. So that concludes question 6. Now, if we look at question 7, question 7.1, we have to determine the length of BC. So at 7.1, what we are going to do is we are going to say that the tan of 30 degrees equals h over BC. So BC equals √3 h. Sorry, let me just go over there. Okay. So remember, that is 30 degrees. We know this angle over here is going to be 30 degrees. Okay. Once that angle of 30 degrees is there, we can make use of our proper trig ratio. Now, ladies and gentlemen, let me just tell you something. Whether the learner wrote BC equals h over tan 30, and whether the learner wrote h over 1 over √3, or whether the learner wrote it as √3h, in all 3 of those cases, it will be 2 marks. There is no such rule that says, but he had to have it in simplified form. So BC can be any 3 of those options there. It can either be h over tan 30, because we just said it must be in terms of that. It can either be the h over the 1 over √3, or it can either be √3h. But we encourage our learners to simplify. 7.2. Now, another question is 7.1. If they made use of the wrong ratio, if they said the sine of 30 equals h over BC, or the cos of 30, it's a breakdown. It must be the correct ratio in 7.1. 7.2. Write down the size of GBC. So we want the size of angle GBC. So when you work with the interior angles of a triangle, you get GBC to be 2 beta. You can do it mentally. And therefore, it's 1 mark that we give there. There's no need to show it. They can just write it as 2 beta. Then 7.3, show that DC equals whatever we ask them. So first of all, they're going to use the sine rule. By saying DC over sine B equals BC over sine D, that is the correct use of the sine rule. So it means like, they didn't say DC over sine B equals sine of D over BC. That would have been wrong. But they just put down the sine rule in a correct manner. So the reason why we give this mark to them without the correct substitution yet is because they needed to identify the rule within the triangle. Now the second step, they go and make substitution. So that is where we give them a second mark. Some of the learners will skip the first part. They will immediately write only the second part. Then they already can give 2 marks. Now the third mark would be where they rewrite the sine of 2 beta equals to be the 2 sine beta cos beta. That would be our third mark. Then where we write the sine of 90 degrees minus beta, okay, where we are actually going to write that as the cos of beta. That would be our co-ratio that we give over there. That's for the cos beta over there. And then they're going to put it as 2 multiply root 3 h sin beta. That would be the 5th mark. You can't give it in the last mark because that was given. So we just stop that one step before it, because now they can say, but 2 multiply the root of 3. If I take that 2 into the root, it becomes 3 times 4, and that is 12. And there's our 5 marks. Ladies and gentlemen, I've been telling my markers over the years, and I'm telling you also this, if you don't know it, for many years at national level, it was discovered that many educators didn't teach 2D and 3D because they said it was too difficult. Now you can understand that over the years, level 1 and level 2 questions has been asked on this topic. So you are forced to make sure that this topic is explained and taught. And even if you look at this problem over here, it wasn't that difficult. It was mainly procedural because it's textbook orientated. Now, if we go into question 8, let me just check if we have any chats over here. 7.3, Albert says, alternative method is the cost rule. Let me just go and look over there. Remember, very specific conditions for the cost rule. Let me just look over there. You've got a 2B, and you've got a 2B. Yes, you can make use of the cost rule. Okay, because of those two, yeah, you can have enough information to also work with your cost rule. It's 100% fine now. That would not be a problem. Okay. So in this case, that's why it says marking guideline. You can then just mark accordingly. Now, if we look at geometry, ladies and gentlemen, with geometry, it's very important that we know the following. The order in which a candidate answers a geometry question must follow logically. You can't skip steps. It must be a very, very, very specific way in which you can actually answer this. Now, to point it out to you, the specific problem over here, it was said that AB is parallel to CD and EFD equals 150 degrees. And now we have to find for X and Y. Okay. So in this specific step, you need to understand that if you first need to find X before you can find Y. You can't do it actually the other way around. So therefore, you have to make sure there's logic in the solution that the learner put. Also, let us look at these abbreviations over here. S is a mark for the correct statement. A statement mark is independent of a reason. I'll explain to you right now. R is a reason mark. A reason mark may only be awarded if the statement is correct. So reason marks are dependent on the statement marks. But the statement mark is independent of the reason. If I say calculate the value of X, and you say X equals 40 degrees, and that is correct, you give the mark. Now, if I put down the wrong reason, I don't get a mark for the wrong reason. Now, if I must calculate X equals to be 40, and I get X equals to be 30 degrees, but I put the correct reason, you cannot get a mark for the reason. We only award a mark for the statement. For the reason mark, the statement must also be correct. And then S/R, that means it's statement reason marks. Both of them must be correct for that one mark. Now, at question 8.1, the question says, calculate the size of F2. So what is the size of F2? F2 equals 90 degrees. You're going to give your first mark there. And what is the reason for that? The line from the center to the midpoint of the chord. Okay. Now, once again, if you look at exam guidelines, those are only guidelines that are given for the wording of geometry. So let us make sure, ladies and gentlemen, this might be a language barrier. So let us make sure sometimes if we can understand, if we can extract the correct strings from what the learner has, what the learner wrote in the answer script. Let us give those specific marks because they don't always phrase it like this, but we really want to see center of the circle, and we would really like to see the word midpoint of a chord. This is what we really like to see in the specific case. Now, 8.2.1. We need to find angle O2 in terms of x. So first off by saying C1 equals x. And what is our reason for that? Angles opposite equal radius. But now look carefully. We only gave a mark for statement. So we didn't look even at the reason. Now the reason for that is because we want our first geometry problem to give the learners some marks that they can have access to. And on a diagram, they can also see it. So C1 equals X, but we would really like to see the reasons. That is how we will teach our learners. But for now, for the marking guideline, we said we're not going to even mark for the reason. And then from there, they can say O2 equals 180 minus 2x, because that is the sum of the angles of a triangle. But we are only looking C1 equals X, O2 equals 180 minus 2x. Now, ladies and gentlemen, if they left 8.2.1 open, but on the diagram, they put X at C1, and they put 180 minus 2x at O2 on the diagram, you can mark on the diagram. Then just take it with arrows to the relevant question. 8.2.2. You have to find that angle DOF or the angle B in terms of X. So we're starting off by saying DOF equals 90 degrees. It's the co-interior angles. AC is parallel to ED. We want to see the statement and we want to see the reason. Why? Because we are almost at the end of question 8. So it means like it becomes slightly more higher order. And for that, we want to make sure our learners know what they are doing. Then the next part is O1 equals 90 degrees minus 180 minus 2x, and that gives me 2x minus 90 degrees. So they're just doing a little bit of algebra over here. Then from there on, I can see that CAB equals x minus 45 degrees because of the angle at the center 2 times angle at a circle, at a circumference. That is 1 mark for the statement, x minus 45, and it's 1 mark for the reason. So it's 4 marks up to now. Now we're going to say that B plus x minus 45 plus 90 degrees equals 180 degrees because of the sum of the angles of the triangle, in this case triangle FAB. It's a statement reason mark. We want to see the statement and it must be supported by a reason. That's what's very important over here. And then from there on, we just simplify and we get a B equals 135 minus x. That was not given to us. This is our answer. That is our 6th mark. Yes, sir, your hand is up. Just unmute yourself, sir. You're still muted. Just unmute yourself. Yes.
Yes, I'm on 8.2.1.
Yes.
Then instead of having statement, it is statement and reason. All right?
At 8 point?
I'm saying on this side where we are marking, we should look for statement.
Yeah.
And then the second one also is statement.
Yes.
Right?
Yes.
Now suppose it was given that it must be statement and a reason.
Yeah.
Now the learner has written 180 degrees minus 2x for O2 and has written x for angle C1. What are we going to do then? Because on the marking guideline, it was given as statement and reason. I just want to know.
Are we talking about 8.2.1?
Yes, I'm saying here we are what marks for statement and
Statement and statement, yes.
Yes, but suppose it was statement and reason for both of them.
Yeah, then it means you have to have a perfect reason. Yeah, I'm listening.
Yes, and the learner has written the correct answers on the diagram without statements.
You mean without
How are we
reason?
doing? Yeah, without reason.
Yes. So that is a very nice question. I'm following you. I'm getting what you are asking over here. What Sir is asking. Remember, I said if they didn't write it there, but it's put under diagram, we can award a mark. But now what Sir is drawing our attention to is, if that was a statement reason mark, then we cannot give that mark, even though it's on a diagram, because there's no reason to support that statement. If it's only a statement mark, we can give a mark on the diagram. But if it's statement, reason mark, altogether as one mark, even if the learner wrote it on a diagram, we cannot give that mark there because we are looking for the reason as well. Thank you for raising that, because I think now everyone is also on par with this. Madisha ML, you also have a question?
Thank you, sir.
Yes, ma'am.
Yeah, suppose on 8.2.2, suppose
Yes.
the learner just write the reason diameter perpendicular to the radius, not co-interior.
Okay, so at 8.2.2, so let us let
Yeah.
the learner say diameter.
Angle DOF is equals to 90, reason being diameter perpendicular to the radius.
Yeah, but remember the diameter cannot be perpendicular to the radius. I'm trying to look over there. We're talking about DOF. No, that's the angle that we're talking over there. Okay, so in this case, yeah. So what's happening over here in this specific case? Remember, the only angle that we know, or what we know that OB is perpendicular to AC because of the radius going radius going through the midpoint of the chord. That is what we know.
Okay.
But now we need to know, why is DOF also
90 degrees.
90 degrees? Remember, if you've got a diameter of a circle and you draw any radius from that center, it's not necessarily going to be perpendicular to the diameter. Do you agree?
Okay.
So in this case,
understand.
that's why we work with the co-interior angles. That's why it's a statement reason mark.
Okay, thank you, sir.
Okay, you're welcome, ma'am. Okay, so that was 8.2.2, and that's our geometry marks, 6 marks that we've got over there. We still got people in the waiting room. I just want to see, I'm just going to admit them. Okay. Now, when we go to question 9. Now, question 9 at 9.1, we start off by saying you've got this diagram over there, and you need to prove the theorem that states the following. Now, ladies and gentlemen, the message we'd like to give to you is that with all theorems, you need construction lines, or this is actually the agreement that the moment they want to prove theorems, they need construction lines. However, and I want to say this very carefully, and I don't want you to take this out to your learners, this is actually the only theorem that you can prove without construction lines. But don't let us tell this to our learners. I'm just making you aware of it. So there may cases be where learners are not going to draw any construction lines, and they're going to put down their thoughts on paper, and they still may be 100% correct. But don't let us encourage our learners to do without this. I will tell you exactly how they can do the other construction line, but we would really like to emphasize, I would really like you to make sure that our learners make use of their construction lines over here. So in this case, a 9.1, we're going to give a mark for the construction lines on a diagram. So if you can see they've joined B and E, they've joined D and C, and they've drawn those altitudes, it must be 90 degrees. That is one mark for the construction. Or it can be writing, draw altitudes, altitudes H and K, and join B with E and D with C. That can also be writing. But if it's there, you don't have to see the writing. So we don't always say it must be in writing. It must just be shown and indicated on the diagram. So therefore, we'd really like to give 1 mark for the construction. Now we're going to say the area of triangle ADE over the area of triangle DEB equals half AD multiplied the altitude h over half DB multiplied by altitude h. Now, this in this case, where the learners without the constructions, they could have said it is multiplied the perpendicular height, because the perpendicular height of both those triangles will be the same. Someone is just drawing on my and yeah. Now the other one is, and then it ends up being AD over DB. Then if I look at the next one over here, area of triangle ADE over the area of triangle DEC, it can be half of AE multiply K, which is a perpendicular height, over half of EC multiplied by K, which is a perpendicular height. If I simplify, I get AE over EC. So that's my third mark. So they can't just write AD over DB for a mark and AE over ECD mark. They must first show the method of finding the area to get AD over DB. That would be the mark. And the method of applying the area and arriving at AE over EC, that would be our third mark that we get over here. Now, the area of triangle DEB equals the area of triangle DEC. Now, same base, same parallel lines. So that's a statement reason mark. We want to see everything there together. That's 4 marks. Then, if we look over there, if we link it together, we know that the area of triangle ADE over the area of triangle DEB is the same as the area of triangle ADE over the area of triangle DEC. We want to see that link for the 6th mark, or for the 5th mark. And then obviously they can conclude AD over DB equals AE over EC. As I mentioned, and as I pointed out, that this is actually one theorem that can be proved without the use of construction line, but we don't want it to go that public. Don't tell that to your learners, but be aware if they may be did without the construction lines. So that's our 5 marks, sorry. 9.2.1, calculate with reasons the value of y. So in this specific case, we are saying y over y minus 1 equals 3 over 2y minus 3/4 over y minus a half. And this is our proportionality theorem and ST parallel to QR. And it's 1 mark and it's statement reason that we are giving over here. Now let's talk about proportionality theorem. They can't just put down proportionality theorem. If you put down proportionality theorem, you must indicate the parallel lines. Otherwise, it's not accepted as a complete reason. So let us make sure it's there. There is our statement reason mark that we are giving in this case. Now, the reason why people can say, but hey, why not the mark for the statement and why not the mark for the reason? Because 5 marks already went into the theorem. That's based on what we are using over here. That's why the statement reason mark. Now, from there, we are doing a little bit of simplification. So your simplification, it can be, what do we define as simplification? The moment the brackets are removed. That is simplification. Okay, so the moment that they went through all the trouble to remove the brackets, that is our simplification. From there, they will make it to the standard form of this equation. Well, they are the standard forms. And then we look at the factors. That would be our 4th mark. And then we would say only y equals 3. If they say y equals 3 or y equals a half, they will not get a 5th mark. They either have to disqualify this one, or they have to mention that it's only y equals 3. Now, the reason why half is not accepted, because the moment I substitute y with a half in here, half minus 1 becomes negative a half. And I mean, we can't have negative of a side over there. Even here, half minus a half, that would give me, in this specific case over here, that would give me, I just want to admit, I see people keep asking, come in. Half minus half would give 0, and you can't have the length of a side to be 0. Okay, so ladies and gentlemen, this is how we're going to do statement reason mark, simplification for getting rid of the brackets that we are going to do over here. Then standard form, factors, and the last one, we really want to see that they disqualified that half. That's very important. Now 9.2.2. Prove that if PKT equals Q, prove that PSKT is a cyclic quadrilateral. So how are we going to do that? Well, the first one is we're going to say that PST equals angle Q. And the reason for that is corresponding angles, ST parallel to QR. It's a statement reason mark. That must be there. Okay. Now, what have we just concluded? We've just concluded that PST is the same as PKT, and that's the same as Q. So in this specific angle, if you look at your diagram, then that means that PSK and T are concyclic. Okay, those points are concyclic points. So therefore, it's converse angles in the same segment. That would be a mark for that reason, and therefore it's a cyclic quad. Remember, we had to prove it's a cyclic quad, so we're not going to give you that last part. So we're giving you a part where you link PST with Q, and where you then mention converse angles in the same segment. That would be your second mark that we get over there. About 12 marks. The whole question is 12 marks, but 9.2.2 only 2 marks. So that concludes question 9. Now we are going to question 10. In question 10, let us look at our problem over there. Question 10, 10.1.1. Check something here. Yeah, it's perfect. It's perfect. I'm going to question 10.1.1. We have to prove that angle C equals angle ABF. So our first mark would be for C equals 90 degrees, and that is angle in a semicircle. We're going to have a circle. Remember that could also make use of the symbol, angle in and a half, and I could put a circle symbol. It's perfect. And the reason why I didn't put it like this is because it doesn't print out nicely on all printers. So that is the first statement, and it's a reason. It's 1 mark for the statement, 1 mark for the reason that we can have over there. Then the other one is ABF equals 90 degrees. That is a statement, and the reason mark is radius perpendicular to tangent. And now, because both those angles are 90 degrees, they are equal. So 4 marks for that whole question. So that question you can only prove by making use of the 90 degrees angle. You can't do it in another manner. So you have to see that 90 degrees for C, and you have to see the 90 degrees for ABF. So our 4 marks. 10.1.2. We have to prove that GF times BC equals AB times BD. So ladies and gentlemen, the moment you see in geometry that we are looking at an equation that we have to prove that the product of sides equals the product of sides, you need to know it's either coming from the proportionality theorem or it's either coming from similar triangles. Now, in the specific case over here, because I don't see any parallel lines, I know it's similar triangles. So I have to look at my triangle. I'm going to say in triangle DBF and triangle BCA. Now, I will just, now just need to remind me here that I will just shortly, if I'm done with this discussion here, before we start looking at those training scripts, I will just quickly show you the short way of how your learners can identify with which triangles they can work with. So I'm working with triangle DBF and triangle BCA, and I'm saying that that angle D2 equals angle B2, and that's angles opposite equals sides. It's statement reason. Now, I want to tell you something, ladies and gentlemen. If you've identified the triangles, don't let them put down D equals B, B equals C. They have to give us the very specific triangles that we can see on the diagram. This was an instruction from National last year. So let us make sure that our learners, otherwise they just start linking it up. Then DBF equals angle C. That is a statement, but it's coming from 10.1.1. And now we know that triangle DFB is similar to triangle BAC because of angle, angle, angle. And that would be my reason mark. And from that, I can put down the corresponding sides, and I can say that DF over BA equals DB over BC. And my reason would be from similar triangles. So that is the first way I could have done this for 4 marks. The second way, because I know some of you are looking at this and say, hey, but listen, for similar triangles, I must put down 3 statements. Not necessarily, because if the first 2 are correct, the third one will be automatically. That's why we've created 2 ways in which we can do this. Well, the other one would be exactly as the previous one, D2 equals B2, statement reason mark. DBF equals C, because it's from 10.1, that's a statement mark. And then we can say angle F equals angle A, and that's a statement mark. And now we know that this triangle is similar to this triangle. And from this, we put down our corresponding sides. DF over BA equals DB over BC. And that is a statement reason mark that we actually get from there. So it's just splitting it up the way the learners may have approached this. Our 4 marks for this question. 10.1.3. The question was, E is the midpoint of the circle that passes through the points G, B, and F. So we have to prove that E is the midpoint of the circle. Ladies and gentlemen, for many of the theorems, the converse do exist. But the converse for angle at the center is twice the angle at the circumference. That converse isn't always necessarily true. So therefore, we need to understand that that theorem doesn't have a converse because there are specific conditions where that will not be the case. So when we have to prove that something is the center of a circle, we cannot make use of that theorem actually. Okay, so what are we going to do in this case? We are starting off by saying that B3 equals A. That is our tan chord theorem. So that we are working with. It's a statement mark for B3 equals A, and it's a reason mark for tan chord theorem. Then from this, we know that B3 equals F, and that equals A. If we look at our diagram over there. So therefore, we can say that BE equals EF, sides opposite equal angles. It's a statement reason mark. Please, educators, let us ban the word isosceles triangles from our grade 12 classrooms because they don't know when to use it correctly. It's either sides opposite equal angles or either angles opposite equal sides that we are working with. So BE equals EF, it's a statement reason mark. And from this, we can conclude that BE equals EF, and that equals DE. So that's a statement they are putting down there, and we want to give them the specific mark over there. And the moment they've put down that statement, they've proved that E is the midpoint of the center of the circle. Because the moment you've got 3 lines that may create an idea, they are radii. The moment you've proved that 3 of them are equal in length, it is that E is the center of that specific circle. So please remember, the converse theorem for angle at the center of a circle twice the angle of the circumference. There's no converse theorem for that, please. Now, 10.2. This is our last one over here. And we always know the last one in geometry is always one where you have to think a little bit, and the learners have to be a bit creative over here. So prove that 1 over BC squared minus AB squared equals negative that of AD multiplied FB over EF times AC cubed. Okay. Now, in geometry, normally we build up from the previous questions. So we're going to say that in this case over here, AC over BF equals AB over DF. Where did we get this from? We got this from our similar triangles that we proved in 10.1.2. Now, what do we know about AB? AB can be written as 2 times AD, and DF can be written as 2 times EF. And therefore, this is the same as AD over EF. That is our second mark. So our first mark is for the statement to say that AS over BF equals AB over DF. That is a statement mark. And also by saying, but listen, that equals AD over EF. That is our second statement mark. Now I'm going to manipulate it. I multiply both sides by 1 over AC3. What I do to the one side, I do to the other side. So therefore we give a mark because they were engineering the solution for this. And now if I look at the left side, it can be simplified as the AC and the AC cubed. They cancel, it becomes 1 over AC squared. And then the BF, I just multiply over to the other side. And I get AD times BF over EF times AC cubed. So that's a statement mark for putting that down over there. So that's 4 marks by now. Now look at that AC squared. And that AC squared can be rewritten as AB squared minus BC squared. So that is Pythagoras that I'm applying over there. And we're going to give the learners a mark for that specific part over there, where AC squared was written as AB squared minus BC squared. And now what are we going to do over here? We're going to say, but if we look at the other side, okay, if I take out the negative commonly, then it becomes BC squared minus AB squared. And there's a reason for that. There's a reason why I want to see that, because that is what the question paper is asking me to get. So I'm going to take out that negative over there, and I'm going to have 1 over BC squared minus AB squared. And that would be the 6th mark, because the last part is what was actually given. So they just can divide both sides by the negative, and then we're going to get that specific answer. So you had to use a little bit of manipulation, and we were actually combining Pythagoras, similar triangles, and a little bit of factorization that we actually combine into this question over here at 10.2. Now, ladies and gentlemen, this basically concludes the marking guideline discussion, the part 1 that we said, let us just look at our marking guidelines, the way we interpret it, to share just a few quick things with you. And we said the second part is, we already sent this to you, was the training script 2 and training script 1. Now, what we would really like to ask is, because I'm going to switch on the visualizer to literally mark it also with you, and to show you how we actually mark and how we count and how we make sure that everything is double checked and everything. So this is also part of the discussion over here. But I know some of you, you may have only printed out and didn't have the time to mark it yet. So therefore, I'm going to say, I'm going to allow you some time. I'm going to ask if we can just ask maybe at, let's say, 3:15, if we can be done with training script 1. If you have marked that, and then there's always the reason for that is because we want to see if you get exactly the same marks that we get. They can also assist you, because we know that many of the educators haven't marked before at national or at a NSS or NCS at the end of the year, and therefore just want to make sure that we can also assist you on how to actually mark. So I'm not going to switch anything off yet. I'm going to give you some time to 3:15 to mark that, and then we will just engage into that specific discussion. Then, Edwin, you've got a question for us? Edwin, your hand is up, but I can't hear you. Maybe you're still muted. Okay, Edwin, your hand is up, but I can't hear you. But that is fine. So once you sorted the sound, then I'll be able to hear. with colleagues. At 3:15, would really like to look at training script 1 to see how you've marked, what you've got from that specific script over there. And then once my document camera is on, then I will also quickly show you the short method of getting or identifying your two triangles. Okay, so we will just carry on from 3:15. Right, ladies and gentlemen, I believe that we are all ready and that you've looked at the script. So I'm going to just share this one with you. And I believe that you all can see it right now. Ladies and gentlemen, I did say that I would just quickly show to you that if we have to identify triangles that we need to prove, those triangles are similar. So I'm just going to give me some a piece of paper over here. In that specific question, so this is just something for teaching that you can just also show to your learners if you're not quite sure or if you haven't seen this yet before. If we say you have to prove that DF multiplied BC equals AB times BD. Now, I'm telling you, 99.9% of the time, if we have to prove the product of sides, it's either going to be that it's going to come from proportionality theorem, or it's going to come from similar triangles. But if I look at this diagram over here, I don't see any parallel lines. So I'm not quite sure if I can go with the proportionality theorem. So my guess is that I will be looking at, let's say, similar triangles. So what I can do now, so this is just a hint for you. You can decide, you can say, listen, I want to keep this one and I want to keep that one. So I start off by saying, I'm keeping the first one, I'm keeping the first one. The others I'm dividing. So if I do this, and if I divide and I look over there, AB over BC, I've got DF over DB. Sorry, that must a BD. I've got over there. Okay, sorry. Let me just draw it right nicer. Okay, now look what I do. I go and I say, listen, what is repeating over here? The D's are repeating. So if I cover one of my repeating letters, I've got FBD. Okay? And I look at my diagram and ask myself, is FBD a triangle? And yes, FBD is a triangle. Then I'm looking on the other side and I'm saying, listen, what letters are repeating here? It's the B and a B. So if I cover this B, I always cover one of those letters that are repeating. I'm left with ABC. And now I'm looking at my diagram and I ask myself, is there a triangle ABC? And I look at my diagram and I see ABC is a triangle. And this is how I know which two triangles I need to prove similar. Okay, just do it always by this trick. It's a lot easier. If you divide and you don't get a triangle, just divide it out of two, then you will get it. Okay, so this is what I've promised you. Now, ladies and gentlemen, if we look at script number 1, I will understand maybe some of you, if we look at the geometry, because this is an Afrikaans learner, maybe of the reasons, I would get that. But now let us just look on how we're going to mark this specific script. Okay, now over here, we look 1.1, and we're going to start marking. Now, this is how we mark at the end of the year as well. Okay, when we mark, we don't make any crosses and we don't make any of those right ticks. Okay, these are normally out. We don't use that. Okay, we either a watermark like this, and whatever is wrong, we just underline. That's how we deal with it. Okay, now if I look at 1.1, the answer is 33, and I put my 1 there, it's 1 mark, and I put my 1 there. So this indicates that it's actually 1 mark that we are actually looking at. Now, if I look at 1.2, on my memo, it's very, very, very clear that I have to look at the product of the frequencies with the mid intervals. So I look and I see, I've got 2 times 22, I've got 8 times 26, I've got 30 times 15, I've got 6 times 34, I've got 83 times 2. It's added. So therefore, I agree with that. and it's divided by 33, and I get my answer of 29,76. In this case, 29,78, but we're not going to penalize for the rounding there. Okay, so it's 2 marks. So it's 1, 1, and I put my 2. Now I look at 1.3.1. If I look at what is written over here, for 2 and 10, we want to give a mark. So therefore, I'm going to make my 1 mark 10. That means I've given it for 2 and 10. And then I ignore everything, and I give the last one there for 33. And I put down there, I've got my 2 marks. Now, if I turn, I'm on the ogive over here. So now we need to be very careful on the ogive if I look at my ogive over here. Now, the first mark is for the grounding. Okay, so normally I put it there at the grounding. There's my first mark that I put it down there. Now I'm going to just check if this candidate pointed everything at the upper limit. So it means at 24, there's a point. At 28, there's a point. At 32, 25, there is a point. At 36, 31, there's a point. At 40, 33, there's a point. So the upper limits, they are perfect. Okay, so my upper limits are perfect. So therefore, it means I just put my 1 there at the last limit. I agree with it. It's 100% correct. That's my upper limits. And now I just look at the graph and I see it's smoothly with a hand drawn, and there's my 3rd mark. So normally at the end of the year, what we would do is we would say, within this specific case over here, we would put a G for grounding, we would put U for upper limits, and we would put S for shape. So this means we would say, okay, for grounding, we are giving 1. For the upper limits, for the shape, we are giving a mark over there. That's normally how we do it. But if you do it like this now, it's perfect. And you just record over there and my 3 marks. That is what I'm going to give over there, because that is what this actually counts. Now, 1.4 and 1.4. I want a value more or less from 16.5 down to 29.8, but I've got this little bit of a margin that I can work with. Now let's look what the learner has done over here. Okay, this learner wrote the answer as 30. Now this is incorrect. Okay, the learner put down the modal group, and then in the modal group, the learner just wanted to take the middle value. This only could have worked if the data was distributed perfectly normal. But now in this case, it was only close to normal distribution, not perfectly normal. So this is wrong. So in this case, I underline it, and it is 0 marks that this learner is going to get over here. Even there was no indication here from reading it off. Okay, so that is 0 marks. So I'm giving the learner over there. Then 1.5. We know we want to have the answer of 4. Now let's look what the learner is basically saying over here. The learner is saying, okay, so if we can look, I've got an 8 and I've got a 6. Okay, now where does the learner get the 8 and the 6 from? Now I'm just trying to get my question paper here. Okay, that 8 and that 6. I will tell you where this comes from. Because remember, when we look at the learner's answer book, okay, we must know that they can sometimes write it strangely. So that 8 and that 6 is coming from 8 is this graph over here, and the 6 is this graph over here. That's the frequency of 6, and that's the frequency of 8. So the learner is saying, but listen, I need to add something there, okay? And in this specific case over there, I need to add something to the 6. So the fact that they're working with the 8 and 6, that's enough evidence to me that the learner has identified the intervals that we are actually working with. Okay. And now what the learner is doing over here, the learner is saying, but listen, I'm adding a specific value there. I'm adding a specific value there. It's not really going to be the same value. So it's like the learner doesn't know really what he or she wants to do here, but they are making use of test and trial. This is what they are doing over here. So I would say this is enough evidence that the learner has convinced me to work with the 8 over there, okay? And for getting the k equals 4, in this specific case, I would say I would give this learner 3 marks, okay? Because the learner over here can see, the learner is trying to work with specific values. The learner is saying, listen, this one needs to be increased by 3. And that one will only be increased by 1. There's the 3 over there, if I can put it like this. So therefore, we have to just look a little bit. And in this case, I would definitely give this learner a 3. And typical example, full marks for level 4 question, 0 marks for a level 2 question. So this also happens now. Now, when we add, because now remember, this is the prep exam, it's very important. So when we add, we first add our ticks. We go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I get 11 marks. But now I start adding here. 1, 2, 3, plus 2 is 5, plus 3 is 8, plus 3 is 11. It tallies, so therefore I know it's 11 marks. So I go to question number 1, and I put down my 11 marks that I've got over there. Now, if we go to question 2. I have question number 2. If I look at the memo, the learner has immediately put everything in there. So therefore, it means the 10.85, the 0.9x I want to see, and it's the equation. There's my 3 ticks. So I put my 3 there. The second part, 2.2.1, the learner did substitute the 46. And I think this is what Madi Singh were asking about. Someone did ask about it. The learner substituted the 46, but the learner got a 52.08. It's perfect. So what happens is the learner is showing you, but listen, I'm going to substitute the 46, and they make use of the calculator. So what they're basically doing at a calculator is they're choosing the y hat, they put the 46 in front of it, and they just press equal, and then they get this answer over here. So in this case, I will give the learner the full marks that the learners must get over here. There's my 2 marks over there. Okay, so they can do this. They can show they're going to substitute it, but they're going to give the calculator answer because they want to show you that they've substituted 46. 2.2.2. Remember what we said. In this specific case, okay, we wanted the yes, or in Afrikaans, the ja. So that's our first mark. And then we want to know about a strong correlation, or we want to see R equals 9.4. Any one of those two. So I see the R equals 9.4, and that's the same as strong correlation. Okay. But now the only thing is over here is, if we read it over like here, it's not like we can say, okay, do we see the yes or no? We don't see it. But look what the learner is writing. The learner is saying, and this is a good indication. So therefore the learner answers, because we ask whether it's a good indication or not, and the learner said it's a good indication. So in English, some of the learners may also not specifically write yes or no, but they may say it's a good indication, and therefore it's 2 marks. And then at 2.3, it's only B that we will accept, and we give the mark. So in this case, we can say it's 3, and 2 is 5, 7 is 8. Now let's start counting the ticks. 1, 2, 3, 4, 5, 6, 7, 8. 8 marks. We don't want to make any mistakes. We put down 8. There it is. Okay. Now, when we go to question number 3. Well, it's there. F, the method, the answer, it's 0 and it's 5. It's our 2 marks, and we give our 2 marks over there. 3.1.2, the gradient of GF. There's the method, there's the substitution, and there's the answer, and I put my 2 there. 3.1.3. The learner said that tan of alpha is the gradient of GF. It's linked. Now, if we look over here, look what happened over here. The learner already started to solve the equation. So this implies that the learner had tan of alpha equals to 2. So therefore, it was equated to it, and there's my answer. It's 2 marks. So it's just a proof that sometimes if they write it in another manner, it's still 100% correct. y equals 2x, that's all we wanted to see. There's our mark. Okay. If we carry on, let's look at 3.3. We want to know why those lines are parallel. And look what the learner is saying. The learner is saying that the gradient of df equals the gradient of OB, and that equals 2. So the learner knew that we had to look at the gradients. So therefore, 1 mark, and I'm indicating the 1 mark over here. Now you can see here's a little bit of scratching going backwards and forwards. So this means that this was a little bit of complex because the learner had to think about it. Okay. Now, from this, we need to tell ourselves what are we looking for. And the very first thing I can tell you, if we want to break it up, we want to know that area of 9x squared. The moment the learner works with the 3x, somewhere we need to see that. Okay. And look what the learner is saying. The learner is saying over here that the distance of SR is 3x. This is what the learner is saying. Okay. The learner is also putting the distance of OR to be 3 minus 3x. So that is perfect. And then the learner is even giving you the equation of S. And the equation of x is 3 minus 3x, comma 0.3x. So those are already my 3 marks because we could have worked with any sides of the square. And I just didn't put in all of those for you over there. Now, look what the learner is doing. Now the learner is saying, okay, now I want to substitute, okay? And the learner is going to substitute into the line y equals 2x. So there's a mark for substitution, okay? So, oh no, there's no mark for substitution. There's only a mark where we get a value of x to be 2/3. So do we see that up? Here's a 2/3. We give our mark. Then we see there's no mark for substitution. The substitution comes into coordinate. And there is the 1, and there's the 2. 1, 2, 3, 4, 5, 6. 6 marks that the learner managed to actually get over there. You can see over here the learner wanted to work with a distance formula, but realized they didn't have enough information. Okay. Now, 3.5. If we look at 3.5, we want to know why it is a parallelogram. Now, the first one is why the learner has to say that E equals the midpoint. Okay, that can either be the case, okay, or what can be another case is when they can either work with the diagonals. Okay, now the learner is saying that EF is parallel to OB, that was proved. AF equals FB, that was given. AE equals EO. Okay, so why would the learner then basically say that? I just want to quickly check on my diagram over here. The learner said that EF equals OB. Now it's parallel to OB, yes. And AF equals FB. So the learner is saying that OE equals EO. So this part over here, by saying that OE, that AE equals EO, what is the learner actually saying? The learner is telling you that E is the midpoint of AO. This is what the learner is telling us. The learner is telling us that E is the midpoint of AO. Okay. Now the learner goes and the learner calculates the midpoint of AO, and that is -3/2. So the learner illustrated was the midpoint, AE equals EO, and the learner calculated the midpoint to be that. Now the learner is saying, look at the y. The y of E equals the y of S, that equals 2 marks. Okay. Therefore we can actually say that they are parallel. Okay. So both these together here will get 1 mark because y, and they say therefore it's parallel. There it is. Okay. It's 1 mark. And then they say EDO is a parallelogram because 2 of the sides are parallel. So 4 marks, even though slightly written in another way. Here was where the learner illustrated to you that E is the midpoint. Okay, so we have to look at it from another way sometimes. So let us add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And if I look over here, it's 6 and 7, it's 8, 14, it's 18. So that gives us 18 marks. We can put it down there. Now, question number 4. What question number 4? Once again, how are we going to mark this? We're going to say at question number 4, we are only looking at the left-hand side. Do we see the x minus 2, y minus 4 according to our marking guidelines? Yes. There's the 1 mark. Do we see the right-hand side to do 100? Yes. So therefore, it's 2 marks. 4.2.1, is this the coordinate we want according to our marking guidelines? Yes, there it is. So it's 2 and the 4, 2 marks. 4.2.2, this is what we want to see according to the marking guideline. So this is our mark for x equals 10. Now, if you go to 4.3, 4.3, 5 marks. So break it up for yourself if you want to mark it. We first look at the gradient of QP, the gradient of the tangent, the equation. So what is the gradient of PQ? According to our marking guideline, there's 1 mark for the substitution. So that we have to give. There's 1 mark for the 3/4. Then we are looking at the tangent. The tangent, -4/3, there's our 3rd mark. Then for substituting everything together, there's our 4th mark. And then for getting the equation, there is our 5th mark. So 5 marks for the equation over there. 4.4. What do we see over here? I always like to first look at the answer. So if the method is something strange, I know there's somewhere we have to work with this. Okay. Now, what do I see over here? Okay. The learner is saying that SRQ is 90 degrees. That we know from the diagram. Okay. And now the learner is saying over here, if I can just quickly see this over here, it's some sort of funny angle that I don't really see over here. Let's look at the diagram. So the learner is saying that the tan of something equals the gradient of SQ. So I think the learner decided to put his own symbol there. Okay. Because if I look at the gradient of SQ, okay, on my the diagram over here, the gradient of SQ that we've got, okay, and the learner is saying that the tan of SQ, and then the learner worked with 4/3. Okay, so the reason why the learner worked with 4/3 in this specific case is because they worked within the triangle they wanted to work with. Okay, so they've got an angle of 53,13 degrees. Okay, but now I got 126, and the reason why I got 126 because already in my solution I added 180. This learner decided to make use of a positive ratio and then to subtract it from the 180. Okay, this is what the learner actually wanted to do. So
yeah,
in here to
what?
to explain this to you, the learner was making use of a reference angle. So the learner was looking on that specific triangle, and the learner was actually trying to work with sides over here. But now, what I'm going to do in this specific case over here, so to illustrate this, the learner said that this is a reference angle. And within that specific triangle, the learner said, but listen, the ratio can be 4/3. That's what the learner wanted to do. And then the learner subtracted it. So therefore, in this specific case, I would give all 3 the marks. So don't just go and tell yourself, but listen, where does this angle come from? So what the learner has done is, the learner is saying, if I stand in this triangle and I make this my specific reference angle that I get over there, okay, or whichever case the problem is, okay, if we can just go back to the specific triangle over there. So what the learner is doing in this specific case, the learner knows that this gradient is -4/3, okay? But if the learner is standing in the specific triangle, because the learner wants to work with the angle of reference, okay? So with the angles of reference, okay, what is tan, okay? It's opposite over adjacent. So he knew it's going to be 4/3. 3 within the triangle. So this is what the learner tried to do over here. So therefore it's 3 marks. Okay. So that is just 0. Let us see what the learner was actually trying to illustrate over here. Because if that side is 4 and this side is 3, this gradient will be 4 over 3. But because of declining, it's a negative. So the learner only tried to work within the triangle. Okay. 4.5. What is the learner doing over here? Okay, so the learner wants to give us, once again, very, very funny method, but the learner has calculated the 48 units squared that the learner got over there. Okay, now let us see what is actually basically happening over here. So the learner is saying, or the candidate is saying, if I look at a perpendicular height, okay, whatever my perpendicular height is, the learner is saying that the perpendicular height is 10 minus 2, and that equals 8. Okay, now what I can show to you, if we go back to the diagram, okay, here's the diagram of the learner. Okay, if I draw a perpendicular height over there, okay, on my diagram, if I draw perpendicular height there, what is the x value there? The x value is 10. What is the x value here? The x value is 2. Okay, so that's 2 comma 4. So that 10 minus 2, this gives me this perpendicular height to be 8. This is what the learner has done. The learner has worked with this perpendicular height over here as being 8. Okay, so that explains to you what the learner has tried to do there. Okay, and now the learner is saying, but listen, I'm working with x minus squared plus y minus 4 squared equals 100. And now the learner wants to put in the t, okay? And the learner is saying that 10 minus 2 plus 2 minus 4 equals 100. T equals 10 or t equals negative 2. So the learner gets that to be actually negative 2. Okay, so what I'm just want to say is, okay, so the learner tried to solve for t, and the learner managed to get that t equals negative 2. And to get t equals negative 2, the learner managed to get QR. So where's QR? So QR is this part over here. So by solving 2, the learner got negative 2, okay? And by getting that to be negative 2, the learner find this to be 12. So this is what the learner did. So I understand the 12, I understand the 8. And now what the learner is saying, but listen, if I work in this beautiful triangle over here, what is the area? Half of base times height. It's the half of that 12 times 8. And this is what the learner has done over there. The learner said half of 12 times 8. That's 48 units squared. So once again, ladies and gentlemen, the learner didn't use what we made use of under diagram. The learner wanted to make use of his own triangle. So in this specific case, if we have to award our specific marks, okay, how are we going to award our marks to make sure that we can be consistent with the memo? If you look over there, there is a specific place where we give a mark of 12. Okay, so the mark of 12 is there. So I would say the specific mark of 12 is here. The learner made use of this formula, and not of the sign formula or the area formula. So the formula would give a mark. The answer would give another mark, and I would say that 8 was very important in solving this, so therefore it's 4 marks over there. So the learner actually made this problem or solved this problem without using the area rule, and it's 4 marks. Now, if the learner didn't put a 48 there, and you only saw this, then some of you may not have looked for any marks. But there were quite a few things that said, but listen, I have to look at something. I saw 12. That is what I saw. I saw the answer of 48 over here. And I saw reasoning without any cancelling. So it was like this learning exactly what he wanted to do. But that is where I explained to where the 8 comes from and where the 12 comes from. And then it's half base perpendicular height. Now let's look at 4.6. What did this learner do over here? This learner is saying, but listen, it's not always writing very nice. From negative 8 up to 2, and is K, and he says from 2 to 12. So that was given. Now the learner is saying from 3 to 12, that is the same as K minus from 2 up to, and I can't see what's standing there. So that is what's a little bit of a bothering to me, okay? Now that means I will have to look at it. I would have to now give the learner the benefit of the doubt. And over here, what's happening over here? The learner is saying, I've got K minus the function value at 2. And what is the function value at 2? The function value at 2 is 14. So in this specific case over here, what the learner is saying, but listen, if the sum of everything is K, then I can say, but listen, that from 2 to 12 is K. Then I can say, but from 3 to 12 is the same as K minus from that value up to that value. And what does this value up to? This says from X equals 2 up to X equals 2. So the learner is looking in that specific point. So once again, the learner is absolutely correct in what the learner is saying over here. So that part over there, we couldn't see clearly what's standing there, but looking at this over here, the learner implies. We know exactly what we see over there. So in this case, we're going to give our 4 marks. Okay, now how are we going to do those marks? This very first part over here, this is deserving of a mark. For the h of 2, that is 14. Well, here it is implied, because h of 2 is implied to a 14 that we get over there. Okay. For writing that this partial parts over here, that's a mark on our memo, and for getting our final answer to be 4. We can't say, but this letter then shows that h of 2 equals 14. Over here, if h of 2 is removed, there's the 14. The learner is showing you it's 14. So therefore, we have to give our marks over there. If we add it up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. This is what I get. But now let us check. 2 is 5, 10, 13, 17, 21. So we are quite satisfied. We can say we believe that is 21. There it is. Okay. Now, if we go to our following question, question 5. What question 5? If we look, everything is more or less on the memo. We can say 5.1.1 is 1. 2 marks. 5.1.3, it's sine of 2x plus 30 degrees. So that's not the answer. The learner is saying, here's my answer. The learner is just showing you, but listen, the translation. Negative 75 or x equals 15 degrees. Those 2 values will get my mark over there. So sometimes we just check it, and you have to check everything. 5.1.4 is from negative 68.53 up to 90. But that one is excluded, that one is included. Yes, so it's 2 marks. Then we give out 2 marks. So I first look at my critical values, then I look at my notation. 5.1.5, m equals negative 45 degrees. Yes, there it is. It's 2 marks that we get over there. So you must give 2 marks for, so the first one you're going to give is where the learner shows you how the function was shifted. And then for a negative 45. Now, if you look over here, you can see it's like the learner wanted to show it there, but immediately saws that. So therefore, we can give our marks over here. It's 4 marks. It's 2 marks. The learner knew about the shift and everything. 5.1.6, b equals a half. There we give the marks. And 5.2, let us see what's happening over here. So the learner knows that gx minus fx must be greater than 0, and the learner knows x must be greater than 0. So this is actually nice in knowing this. Okay. Now let us look at the value over here. Now what's happening over here? The learner has the 68.53. The learner has the 90. But look what the memo is saying. The memo is saying we want accuracy. So accuracy means that we must have the correct notation. Now, in this case, the notation is not correct. So therefore, this learner, underlining it, is 0. And you might think that this is cruel, but this is a higher order question. So, a pity, because of incorrect of that, the learner didn't get those marks. So, let's count 1. And you can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I get 10 marks. And we already counted the other quarter, it's 10 marks. Question 6. Let's see what's happening with question 6. At question 6, the learner is making using of Pythagoras, x equals -7. There's the Pythagoras, there's the x value, there it is. 2 marks. Okay. Now, 6.1.2. We are first giving a mark for negative tan theta. There's the negative tan theta. We're happy. The learner is substituting, and I get 24/7. There's 2 marks. Okay. Remember, many of these diagrams, you don't always need a diagram, but it just makes your life a lot easier. Then when we go to 6.1.3, so what's happening over here? I see my answer of 106.26. But if I look over here, the learner has done something else. Okay. Now, the learner decided to work with the sine of theta. Now, if I work with the sine of theta, if you look on your diagram, the sine of theta in this triangle is defined by 24/25. It's y/r. So the learner is saying that the sine of theta, I can't really see what's standing there, but here I can see it's 24/25. And this is coming from that step over there. It gets a 73.74. You subtract and it gets started in 6.26. So our first mark was for the angle. Our second mark was for the final answer. That's 2 marks. Okay. Because this ratio is also correct according to the diagram. The learner also could have said that the tan of theta. What is a tan of theta in this case? The learner could have said a tan of theta in this specific case. Okay. I could have worked with 24/-7 if I wanted to. The cos of theta, I could have said -7/25. All those ratios are ratios that we can use over here. Okay. But why did we choose the ratio that we wanted on the marking guideline? Because that was the previous question, was set on that ratio. That's why we used that ratio. 6.2.1. I get an answer of -0.5. The learner's got an answer of -0.5. Let us see if we can get what we want to see. The memo is saying negative cos 60. Negative cos 60 is the same as negative sine 30 degrees. So there it is. The tan of 45, there it is. And there's the negative sine 20. You can see there's the negative and the sine 20. So it's there. And then we get our answer of -0.5. 4 marks. Remember, negative cos 60 and negative sine 30, exactly the same thing, co-ratios. 6.2.2. Let's see what the learner did over here. Yes, the learner did make use of the difference of square patterns. So therefore, this is a mark. Where the learner identified cos of 30 degrees, that's a mark. Where the learner wrote the identity of -2 sine x cos x, there's our third mark. And then we are looking for our last mark over here to be -√3/4. So there's our 4 marks that we get over there. So we have to constantly look at what the learner is basically doing. This negative over here just comes from this negative that's left. Number 6.3. If we look at 6.3, let's see what the learners do. Okay. So, yeah. So as you can imagine, what's basically happening over here, the learner is taking out the 4, and now the learner is going to start working on the inside. So the cos of 90 minus 2y, there's the sine of 2y. That gets a mark according to our marking guideline. The cos of 2y, there it is, it gets a mark according to our marking guideline. When we look at the compound angle, there's the compound angle. That is third. when we look at our double angle, here is the double angle part. That's 4, and our answer is 8T. There's our 5 marks. So we have to look for those marks. Then question 6.4.1. If we look at 6.4.1, so in this specific case, we said that must be 1. The learner is putting as 1. He's changed the tan squared x over sine squared x over cos squared x. You just rewrite the 1 as cos squared x over cos squared x. You add it up, and that's where we stop. There's the 3 marks that we must put down. Now let's look at 6.4.2. The learner is saying this plus this plus this equals this. The left-hand side is the square root of this. And now what the learner is saying, then he says no, that ATA isn't correct. So obviously, the no is wrong. We underline it. Okay? And also, the learner hasn't proved anything here. So therefore, the learner gets 0 marks for this question over here. Once again, easy question, and the learner slips with that one. Then 6.5. Let us see what's happening over here. The cos to x is 1 minus 2 sine squared x. The learner got it. Now, look what's happening over here. The learner is making use of the k method. The learner is saying, let 2 to the power 2 sine squared equals k. So now the learner is doing all of these wonderful things. Now we have to say, okay, how are we going to go about this? Okay, well, the first thing would be to say, okay, but we have to look in our specific way that we want to see that 10 over k. And here's the 10 over k. Here's our standard form. And I think there was one for the factors. Here are the factors. And now the learning is saying if k equals -5, it's not applicable. So there disqualifies it. There brings everything in, and we stop at sine squared x equals a half. So it's 1, 2, 3, 4, 5, 6 marks. It's there. Let us add up. 1, 2, 3, 4, 5, 6, 7, 8, 9. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. 28 marks for that question over there. So we can put it here as 28. Question number 6. Then we go to question number 7. Let's see how I did over there. Question number 7, 7.1. Remember what we said, the wrong ratio, then we can't give any marks. But now look what's happening over here. The learner didn't use the wrong ratio. The learner decided to work with the sine rule. This is what the learner decided to do. Okay, so because the learner knew that is 30 degrees over there, and then what the learner is saying that BC, okay, if I've got my BC over here, over the sine of A equals AB over the sine of C, which is 30 degrees. And now what's basically happening is that this learner is starting to basically substitute everything in here. And the learner is getting basically with sine 30, sine 60. The learner is getting h times root 3. And that is my answer that I get over here. So what is BC? BC equals this, equals this, equals this. So therefore, I would say the sine rule, and I would say for getting my answer, 2 marks over there. The reason why we didn't put the sine rule in the marking guidelines, because that is not the way we would like the learners to go. Because remember, in the specific case over here, it was a right angle triangle. Then we want them to make use of our ratio rules. 7.2. 7.2, we just want to see 2 beta. There it is. 7.3, the sine rule, that we can start, substituting with whatever we want to substitute in here. BC over sine D equals DC over sine B. The learner has identified it. Now the learner started to substitute. Now let us see what's happening. Over here, the learner has started to get GC on its own. It's h root 3 sine 2 beta. That 2 sine beta is written as 2 sine beta cos beta. That's sine 90 minus beta. Here, the learner has written it already as cos beta. It's a co-ratio. If you look on your marking guideline, there's a mark for that. And this is where we're going to stop at the spot over here. So there is my 5 marks. If I add up, the learner has 8 marks for question 7. So please with the ratio rule, remember, even if they use the sine rule, it's not the ideal. If you're on a right angle triangle, make use of the ratio rules. It's just quicker and easier. 8.1. So far, it looks like we're all in agreement. We didn't have any challenges. 8.1. What are we looking at? OF is parallel to AC because of the line from midpoint to line from midpoint to midpoint of chord. Okay. Now, what I'm going to do is in this case, I'm only going to give the learner 1. Okay. The reason why I'm not going to give the learner 2 marks is because translated to English, the learner is saying the line from midpoint to midpoint of chord. It's not saying the line from the midpoint of the center. So in Euclidean geometry, we need to be very specific because where is this midpoint coming from? Okay, so in this case, I will not see this reason as something to be 100% correct because we would like to see from midpoint of center. Okay. So therefore, it sometimes, especially in geometry reasons, they can start that it looks perfectly, it's not perfectly always. 8.2.1. In this case, our first mark is by saying that C1 equals X. That's a statement mark. And then by O2 equals 180 minus 2X. There it is. That's my second mark. Then we've got the next one. We want to have, and we see there's the answer. With geometry, it always helps to follow the learners in whatever they are writing in the specific case. Okay. So the learner is saying that O1 plus O2 plus FT. So if we look over there, O1 plus O2 plus FT, they are saying that's 180. Why is it 180? Because of co-interior angles. It's exactly the same as saying that that angle is 90 degrees because of co-interior angles. So he basically just put it in another matter. That's another way. That's how he actually puts it down there. Then we want to have a value for O1. So what is O1? O1 is 2x minus 90 degrees. There it is. Then from there on, we say, but A equals half of O. It's because of the angle at the center, 2 times the angle at the circumference. So, and therefore it's x minus 45. So he gets those 2 marks over there. That's why I say with the geometry, I would understand sometimes if the Afrikaans was a bit of a challenge there. But this we should have seen over there. This must be there. Now, and then from there on, what is the candidate basically doing? He's adding it up to work with the angles of a triangle or the angles on a straight line. So he decided to work with the angles on a straight line, and he gets his angle to be that. Okay. So in both cases, the reasons were given 1, 2, 3, 4, 5, 6. So this candidate scores 9 marks out of 10. Put it there at question 8. It's 9. Then, when we go to question 9, question 9. So once again, there's a lot of writing, but if you look on a diagram, there it is. There's my mark for the construction. You don't have to do it in the wording. You even could have left out the wording. You just could have shown it there. Okay. Now, we are working with the area of triangle ADE divided by the area of triangle DEB. Half of AD times K, half of DB times K. It's perfect, and that leads to that. The second part is perfect, and that leads to that part over there. And now he's saying that the area of triangle ADE is the area of triangle ADE, it's common. But the area of triangle DEB equals the area of triangle EDC, and he says it's the same basis and the same heights, which is perfect. That's a statement reason mark that we can give over there. And now for a fact that is linking the areas, because this is what we want to see for linking those areas. 1, 2, 3, 4, and the construction, 5 marks. Please, colleagues, be aware. This is one of the theorems where we didn't need a construction line. If the learner put here perpendicular line, we must have accepted it. But please don't go and tell that to your learners, because then they might try to do the other theorems as well. And it's only with this one that we can actually do it. 9.2.1, let us see. Y over y minus 1, that part over that part. And now you can say it's a proportionality theorem, but then you have to put the parallel lines. Now, in this specific case, once again, I'm going to be mean, okay? Because this candidate is writing line parallel to one side of the triangle. So it didn't indicate the parallel lines. So in this case, I would just say I'm not agreeing with that part over there. Okay, because say that lines parallel to one side of a triangle, that just means that the other two sides may then be also in proportion. But with the proportionality theorem, we want them to state the parallel lines, and he didn't state the parallel lines. So this is something that's very important. Now, if we do a little bit of algebra over here, simplification, the moment the brackets are removed, then we look at standard form. It's 2y squared minus 7y plus 3. We look at those beautiful factors. They are there. And then we get y equals 3. Y equals half. Do you see he disqualified it? And even here he elaborated on that. So in this case, I'm going to give him 4 marks. Please, I'm telling you, this is the same way it's marked at the end of the year. With proportionality theorem, you must put the parallel lines. So the learner, even if the learner just wrote here, ST parallel to QR, you would have get his full marks, even if it didn't write that. But we want to see those parallel lines. It's very important. So please make sure that the learners are also aware of that. 9.2.2, PKT equals Q. Then also, let's see what we've got. That's given. Q equals S because of corresponding angles, and you stated the parallel lines. There's the 1 mark. And then our second mark is for converse. And here he puts it, converse angles in the same segment. So there's 2 marks that we can do there. So in this case, 4 plus 2 is 6. And the previous 5 is 11. But you count all of your ticks to make sure it tallies. Otherwise, you can make a mistake easily. It's 11. Now, the last question over here. The last question over here is where the learning is saying C equals 90 degree, angle in a semicircle. That's perfect. Remember, I said that's the other symbol, but I didn't put it on the marking guidelines because this doesn't always print on all printers. So, and that was what we were afraid of. ABF equals 90 degrees, tan chord, or the tangent perpendicular to radius. So perfect, and there's the 4 marks. We don't even look at anything else. That's what we want to see. 10.1.2. Okay. The learner started by saying that C equals ABF. Okay. So that angle C equals ABF. That was already proved, yes. D2 equals B2. And it says its angles opposite equals sides. Yes, that's a statement reason mark we will give. Then F equals A. So we can say that first word over there is also there. And then I'm looking over here. It says that these 2 triangles are similar. It's angle, angle, angle. There's my 3rd mark. And from that, it writes down the parts that are in proportion. So he says that BC over AB is the same as BD over DF. Okay, now what I want to say is, if you look over here, remember with ratios, you can either put it in this way, or I could say DF over DB is the same as BA over BC, exactly the same. So DF over DB is the same as BA over BC, and that's exactly what the candidate over here then from this actually draw this conclusion over here. Okay, so in this specific case, we can say, but this concludes it, it's there, and we are convinced. It's 4 marks. If we turn around, ten point 1.2. Now from here, what we are looking for is we want to know that E is the midpoint. So we are looking for sides that must be equal. Okay. Now the candidate is saying that B2 plus B3 equals 90 degrees. Okay. So in our opinion, that is correct. Okay. Now the candidate is saying that DF is a diameter. Okay. So what he's basically saying is that if I've got a diagram like this will always be the diameter of the circle passing through ABC, because you do get converse angle in semicircle. So that we can make use of. Okay. So in this part, because the 90 degrees, the candidate has that part over there. Okay. And he says converse angle in half circle. Okay. And now he's going to say that DE equals BE, and DE and BE equals radii. So therefore, E is the midpoint of this specific circle that we get over there. Okay. Now, remember what I said. If I get a situation like this, and I get that is X and that is 2X, this doesn't necessarily mean that this is the midpoint of a circle, because the converse doesn't exist on this one. But the moment we've got a line that's a 10 and 90 degree angle, okay, then that means, okay, in this specific case, then that line must be a diameter. Now, if we look on the drawing, what the candidate is trying to explain, because remember marking, it's about the decision making. Now, the learner is saying, look, B2 plus B3, that is 90 degrees, okay? And the learner is saying, this line over here is basically subtending that line over there. So why is he saying that? Because of the converse of the angle in a semicircle. And then because the angle in the semicircle, the candidate goes on by saying that DE equals BE. Okay, so that is what the candidate is basically saying over here. And so therefore it says E is the midpoint of the circle. So that's basically it, because if this is diameter and this line equals this line, then E must be the midpoint of the circle. So in this case, we would give this learner actually full marks. Now that 90 degree was already, so I'm going to say for a fact that is a diameter, and he gives the correct reasoning to that specific point over there. Okay. Then also, I'm still looking for another points over here, and that is the only point we can actually give this is by saying, but that these two lines are equal and they are radii. So that is where I would actually give my full mark. So he just did it in another way. But please remember, the converse of angle in a half circle that we can use, but you can't use it on any other case except when it's a 90 degree situation. So there's my 4 marks. Then 10.2. If I look at 10.2, now, I don't know about you, But the moment you look at 10.2, it starts here and it goes on here. Now, if I look through this, the first part of this is the land is actually trying very hard to convince us that AC is parallel to DE. Okay, so the land is trying very hard to convince us that AC is parallel to DE. Now, everything makes a little bit sense up to here. Then it's very difficult to actually start getting his reasoning. So because the learner has failed to actually prove that part, okay, we still go through it and we see for what we can get. Now, if you look over here, and everything's still going together, there's the Pythagoras mark. Because the moment the learner can show to you that AC squared equals AB squared minus BC squared, it means that we are actually allowed to make use of Pythagoras. That we can actually basically do. So there's my Pythagoras mark that I will give to the learner over there. And then the other mark comes in for the ratio AC over BF equals AB over DF. Now look at the learner wrote over here. The learner said that BF over DF equals AC over AB. And this is what I've told you. I can say AC over AB is the same as BF over DF. So AC over AB is BF over DF. So that is a statement mark that I can also give to the learner. And then everything here, because he built everything around that argument that he couldn't prove, there's nothing else that I can actually, from this side, get to actually award him any more marks than the marks he already can get from that part over there. So in this case, I will only give him 2 marks. So if we add this up to, and 4 is 6, is 10, is 14. So I get 14 for the last question. So if you add it up, ma'am, now that she added up for us over here, this learner has 138 out of 150, which means this learner is then passing. So colleagues, this part was to show to you how we mark and also how we can interpret questions and how we can look at the different questions and where we have to look. Don't just look for things that are wrong. If you see something that looks right, try to figure out why the learner did it like this, and that would be alternatives. And alternatives you can put on the group, you can comment on that, you can help each other, because we just want to make sure that we strengthen your hands. Colleagues, I think this is where we're going to stop because we only set at 5:30 and we're not going to have more time. The second question, script, if you want to mark it, I think mine now already she did mark it. So if you mark script 2, the score that she got there is 27 out of 115 that she managed to get. You can just quickly copy it there, your mark allocation per question, and you can just see whether you're going to agree or not agree with this over here. But that's it. So ladies and gentlemen, thanks a lot for joining in on the session. I hope that some of you, that you feel that you are more empowered now, that you know how to mark, that you will know how to approach the marking process and everything. But also, please, when you are done with this and you are doing the final preparation for the grade 12s at the end of the year, please revisit the Northwest question papers of the past 5 years, revisit the national papers of the past 5 years, work according to those papers, make sure they are well trained, and then they will be better equipped then also for the end of the year. Thanks a lot for your contributions. Some of you asked beautiful questions, brilliant questions, and that also just helped to clear some of the points out there, and to make sure that we've got clarity and that we are all on the very same page over here. I'm just going to ask if there are any more questions, or are we all satisfied? Right, it seems like we are all sorted and we are satisfied. So ladies and gentlemen, good luck with the marking, and then also good luck with your grade 12s for the end of the year. But we must keep them positive and must make sure that they do study and work and work and work. Many of you have got my number. I'm on many of the groups. You can just ask there if there are any alternatives. Then we can look at it and we can also then assist you. Have a lovely afternoon.
And from my side,
Thank you, Mr. Smith. Thank you, Mr. Smith.
Pleasure.
from my side, thank you for attending this Zoom session. And yeah, strongs for your grade 12s. And hopefully we will see each other during the December marking. For old time's sake. Goodbye.
You will not see me. Have fun. Bye-bye, everyone.
Oh my God.